right?
Hello.
Oh
Hello.
no.
You thought Brandon was going to be here. Just kidding. I pressed the wrong button,
It
as
might
I
be for the
usually
best.
do. We're back. We're live. I can't believe it's been like 2 weeks since our last show. Hold on. You got a little Mr.
Not
Sandman.
not only that, but I looked at a total episode count, including the shots. It's like 503 is what it said. Which just
We,
makes sense, because I don't think we've done 400 shots.
we haven't done 400 shots.
Well,
In fact,
I guess there'll only be like 300
we need
shots.
to update our topic list from shots.
I do update it.
Oh,
I'm
okay.
the only one who updates it.
Okay.
So where am I seeing
I
that
guess
from?
Mike's just leaving now.
Yeah, I'm the only one who ever updates it.
Yeah, well, I'll leave it to
And
you.
we appreciate that.
Yeah, well,
I mean, I can see 200 shots.
No, we haven't. I don't think we've done 200 shots. I'll tell you how many we've done
okay, all right.
if I can get there.
There we go. I was like, I know that this headphone cable is longer. What's happening? Anyway.
What a week. What a week today's been.
What a week. It's been a week. Oh, it was the ice machine. It was the ice in our refrigerator. We both just heard this like clatter.
All right, so this is episode 161.
Oh,
possibly.
okay. Yeah.
No, it is. It is episode 161.
Definitively.
Okay.
Shots. And we're around 118 for shots.
Oh, okay. That makes more sense.
Okay. I mean, that's fun.
So I don't know where you're getting 500 from.
I just saw that number and some kind of, I don't know if it was Spotify or what.
Oh. Well, I don't know. I don't know. Okay. I feel like we've done more than 161 episodes over the, well.
No, it was 161.
Okay.
I mean, you even put the number in. You updated the number.
Okay.
I'll always check, see if that's right.
We are going to have we are going to do a back-to-back week. We're going to have an episode next Sunday.
Okay.
As our final episode of season 7. And then we're going to take a break and then be back for October. Do I have a new tattoo? I don't have a new tattoo. Which one are you looking at? My ray gun's relative from earlier this year, and then I do have Stella the Star Lady. That she's the most recent one. From like a month ago.
Your ray gun.
Okay, yeah, my ray gun. My ray gun was from March.
Yeah.
Yeah. No Occult Tattoo. Nicole Royce, No Occult Tattoo in Seattle.
Oh, No Occult.
Yeah,
okay.
like that's the shot. That's the shop.
Mike, how's your tattoo looking? Nice.
Yes, he just got this, and I butchered the second skin putting it back on. But it is Gandalf the White Staff. It's in progress. He's got more color to do on it. But it looks phenomenal.
It'll be finished up on the 22nd.
Yeah, so White Rabbit Tattoo Collective in Eugene, Jade is the artist for that one.
Yep.
Yes.
So if you are in the Eugene area, check out White Rabbit Collective. They, Jade does amazing. They all do amazing.
All of their artists. We have tattoos from pretty much almost everybody there except their newest artist, who recently got there.
That guy?
Yeah.
Yeah, I talked to him.
He does some really good stuff. He did this amazing owl I saw on social media that was like blew me away. I don't know his name.
I think you have done most of them. I haven't.
Yeah.
I usually go to Jade. There was some guy who
he did my
penguin
and my UFO, but he's at a different shop now.
Yeah. Anyway. So, but I mean, seriously. If I find an artist and I'm a good artist and you will ride with them for a very long time. Yeah. But yeah, Jade, I basically gave a bunch of elements to Jade. Liz came up with the idea for the stained glass, but I wanted it to be like a stained glass that you would find in Rivendell, and so she came up with that. And
Katie, get your second tattoo, a flash tattoo this Saturday at your summer work party. Ooh,
all right!
I can't wait to find out if
you know what it is
and what you're gonna get. That's exciting. Yay!
So.
Tattoos
All
are
right,
fun.
so this is our episode on tattoos.
Yeah. No, okay. No, we should get.
We should
into
completely
it.
do an episode on tattoos.
Tattoos in space. How to tattoo in space. Ooh, a
The
flower.
same way that you do.
But a lot more wiping off.
Yeah.
Just all like the little blood and whatever is just gonna go everywhere. Little bubbles of blood. Bubbles of blood. Ooh, that's fun.
That's a
New
Halloween
Band-Aid.
drink.
That's
right
gonna be a
there.
Halloween drink right there. I know we were hoping to use the bubble gun for our drink, but we learned that it doesn't sit on top of egg white.
I didn't think it would. But
ooh, the tattoos could change color with radiation exposure. There you go.
That's-
you know when
that's
you're
how
getting
you
too
know
much,
you've been in space
you
too
get
long.
too much
Yeah.
cosmic rays. It's like warning. Oh, okay. All right. You won't accidentally nap. That's fine. You can nap if you want. We don't take
There are no
offense to
accidental
it.
naps.
But wedding work. Okay, let me know if you need any help with your wedding stuff, even though I'm far away. Okay, let's get the show started.
Anyway,
You ready?
focus.
Give me a counting.
5, 4.
Hey everyone, welcome to another episode of Cosmos with Cosmos. I'm Liz.
I'm Mike.
I'm Brandon.
And today's episode is another edition of High in the Sky for September of 2026.
Oh man, that's crazy.
Fall
Are we
is
sure it's not
coming.
2023?
Oh, is that a better year?
I don't know. Are there any good years anymore?
No. Anyway, what are you drinking today?
Oh gosh, right into that?
Mike? Yeah, because you forgot to do it up front last time, so I'm make sure we do it from this time.
This is I'm calling it quantumly entangled.
Quantumly entangled.
Oh, that's nice.
It is entangling regular white rum and Jamaican rum.
Ooh.
We're
entanglement.
We're really kind of at the
Quantrum entanglement.
Hey, quantrum entanglement. So that, and it's also got grenadine, cranberry juice, and
That's
pineapple
nice.
juice.
Ooh.
It's basically a bastardized rum punch.
Tropical. Is your other drink the same?
No,
Okay.
no.
Show your other drink because the color on it is really pretty. It's just this nice, pretty pink color.
Yeah, this
Looks
is
nice.
just cranberry juice.
Just gonna.
Cranberry juice
I don't know.
with rum and a little bit of pineapple juice just to top off because we're running low on everything.
Oh.
Gotta make a run.
Finally doing it. I know. I killed the gin last night with my lavender gimlet with a lavender bubble on top. Brandon, what are you drinking?
I have the official Let's Watch Liz Roll Her Eyes drink. And this is just straight up Malibu on ice.
Oh, wow. God, you guys are going
Basic
runny.
each day.
Coconut water.
Oh, it's delightful. It just tastes like summer and sunscreen.
Well, I'm going with the sour circlet, which is just a whiskey sour. Oh, look at the pulp of the what's the word I'm looking for? Lemon juice.
Lemon juice
in there.
Oh, that's
makes it actually
cool.
kind of cloudy. It's very Venus atmosphere.
What did you call it?
The sour circlet.
Sour circlet, yeah.
Oh, and if did I say it was basically just a whiskey sour? It's basically just that's all it is. But nice and refreshing. What?
I just read Jack's thing.
Oh. Jack said, I just woke up from a post-SEPA GPPA conference nap. It was nice seeing virtual Mike on the dome. Yeah, you made your appearance at that conference virtually. Elizabeth likes purple gin and tonics as well. Yay. Yeah, I would love to teleport it to you. If only teleportation. Although, be wary, teleportation can turn you into puppets. So watch the newest episode of Strange New Worlds for
okay, that makes more sense now.
Why space can't kill puppets.
So the whole virtual mic on the dome, it's a dome cast. So he was in the dome cast. Oh. And my whole job was just say, hi, everybody, I'm Mike. That's
all. You're to stay late at work for that. And, Jack has a grapefruit Arnold Palmer.
Always delightful.
Okay, so instead of lemonade.
We don't have grapefruit juice, do we?
I wouldn't trust it. At least, no, we have some.
There we go.
I don't trust any grapefruit juice.
If you don't trust it.
I think we have some in the second fridge.
Okay. I almost went with the Paloma, but
I think we have a little bit of Sprite that we can do.
I wasn't sure, and if we had grapefruit juice, if it could be trusted.
The one in fridge number 1, I don't think we can trust it.
Anyway, if you like our shenanigans here, follow us on all the things at Drinking Cosmos on Twitter and Cosmos everywhere else. Spotify, YouTube, main platforms of our thing. Like and subscribe. Smash that button. Smash those buttons.
Really helps with the algorithm.
If they
more people will watch us.
I don't know. I can't tell.
Yeah.
Whatever. We have The Hangover as our post-show shenanigans. You can see those live or the Saturday following the Saturday that the main show comes out, if you don't catch the live versions. Also, check out The Shots of Astronomy. Some little shortish.
About 118 of them.
Shortish,
around 120.
Shortish collections of us on random topics every other Wednesday. You can find those. One just came out about Cygnus and his best friend. So check that out now on YouTube or Spotify and see what Cygnus did.
I know what my next topic is, and Brandon's gonna love it.
I know what my next topic is, and you both love it. I hope we don't do the same thing, but if we do, be hilarious.
We love all of our topics. If you like us, you might like some of our friends. You can check out Wildixia on Etsy, Wildixia. Also, our good buddy, Mr. Ron Proctor, MrProctorShow.com. You can find him on YouTube.
Proctor
Creative. He works with the Noir Lab down in Kitspeak in Tucson, so he's doing some cool shit, and he's a really nice guy. Also, a really nice, awesome guy is our buddy Jack over at Rolling Bluffs Planetarium in Council Bluffs, Iowa. So you can check him out if you're in the area. Go see and support his planetarium, rollingbluffsplanetarium.com.
And if you tell him we sent you, get a free drink.
You don't get anything.
Get free popcorn.
You don't get anything.
Jack's like, damn it.
It's like, no.
But nobody's ever going to go and say, hey, Cosmos.
If somebody actually does
he probably would laugh.
If that happens, then Jack can confirm it with us, and then we'll send you something.
Skittles.
Yeah, we'll send you some
There
Skittles. We will send you a bag of Skittles if you go to a Jack's Planetarium.
He sent us Skittles.
He did send us Skittles at our very first Skittles, and we still have the note that he sent with it on our fridge.
Mm-hmm.
Hey, if you're joining us, if you're watching the podcast, if you're listening to the podcast, and if you have a drink in front of you, non-alcoholic or alcoholic, it doesn't matter. We got a little drinking game for you, little rules. If we make any Lord of the Rings or Star Wars references, take a drink. Or if, I find a joke that I made particularly funny and decide we should all drink to it, also take a drink.
Okay. Yeah. I mean, that's fair. That's a good one.
Whenever we say drink, take a drink. All right. You guys ready to get high in the sky?
Let's do it.
Woo! Okay, high in the sky, September 2026. Our constellation highlight this month is actually, it's more of technically a fall constellation, I would say, but I'm going with it. And it's Pisces and the Circlet.
Oh.
The Circlet. Ooh, what is the Circlet, you may ask? Well, Pisces.
It's a circle?
It's
like a circle.
A circlet.
So it stops. I'm imagining like the crown I put on my character in the Elden or the Lord of the Rings game. It stops in the center, yeah.
Pisces, of course, is the fish constellation. It's also known in the astrology world as it is a zodiac constellation, as well as it travels along the ecliptic throughout the sky, the plane of our solar system projected on the sky. Does it
travel along the ecliptic, or does the ecliptic travel through it?
The ecliptic travels through it because it's not rotating.
Because the Earth's not in the center of the universe.
Yeah. It just happens to be our perspective of the stars that make up the constellation that we're like, hey, that's fish.
Look at fancy physics punk over here.
Look at you. Gosh. I got some stuff for you later. The circlet.
I saw.
The circlet is an asterism that's part of the Pisces constellation. It makes up the western fish's head. The western fish head, and it's this little circlet of stars that has been.
I bet you that's going to be Trev's favorite constellation because he likes to go fishing.
He does like go. He's going to be so happy that you mentioned him in the podcast again. Very excited. It is south of the Great Square of Pegasus. Now, Johann Hevelius.
Oh, it sounds familiar.
Yes,
Never heard
you
of
may
him.
have seen his constellation drawings in a planetarium at some point. Some planetariums use those. He divided the constellation of Pisces into like 4 subdivisions. There was like the North Fish, the South Fish, the North Chord, and the South Chord. And Pisces in the sky looks a little bit like this. So you can see these 2 lines, and I don't know how these are fish, but they're fish. And then the circlet makes up part of that western head of the fish. It's more like I don't know, like one balloon. Or
where the string gets really kinked.
Yeah, and one balloon got lost, or like I don't know, somebody had like a lollipop.
You know what they did way back in the day is they had their own version of Cosmos of Cosmos.
They just
it didn't broadcast it, but they would go out and have drinks, and they would just make shit up.
Yeah.
Kind of like we do.
Yeah.
I was gonna say that sounds familiar.
Yeah, we'll just do that. So the stars, some notable stars in Pisces. You have
Notable for such a dim constellation.
It is a dim constellation. You can see the circlet, and you can make out Pisces with dark skies or good night sky conditions. I think you can see the circlet from even like a light polluted area, but it's not necessarily like a standout.
You can see it here.
Thing. Well, yeah, we have nice dark skies
here. Nice dark skies.
Where we're located. But you have there's a hot blue star called Fum al Samaka, Arabic origin, which lies just west of the circlet, and that marks the mouth of the western fish.
Oh, okay.
So that's the mouth of the fish, Fum al Samaka. It's 492 light years.
That's
from
relatively
Earth.
close.
Also, in Pisces, I'm gonna get to a couple that are in the, actually, no, wait, do I highlight just one in the circlet? Yes, I do. I only highlight one in the circlet. Okay, the circlet is made up of 7 stars. None of them have proper names, like Amal.
Because they're all dim.
Amal Samaka. Mm-hmm. Yeah, so it's like, they're like a gamma situation. So Gamma Pisceum is the one that I'm going to focus on in the circlet. It is the
brightest star.
It is the brightest and westernmost star of the circlet. The third most brightest star in Pisces.
Was it Alpha, Beta, Gamma, Delta, right? Gamma is the third one, right?
I don't know if are they always in brightness order?
Mm-hmm.
Oh, there you go then. It is the second brightest star in Pisces.
Well, they got their letters all mixed
My next
up.
bullet point. It's a very old star with an estimated age of about 12 billion years, so fairly old given the universe is 13.8 billion years old.
Wait a minute, how old is it?
12 billion.
Oh shit, that's old.
Yeah. It's very old star.
It's like an Ishtari star.
Almost as old as...
Oh, do it. I am.
Oh, I thought we were going for my reference, but that's okay.
What was your reference?
Yeah, what did you say?
Ishtari. It's old.
Oh, yes. Okay.
Right,
2 for 1.
Bring for that one. We're hitting it off. Okay. All right. Anyway. It's around 135 light years away. It's a yellow giant. It's much larger than the sun, but it's slightly less massive.
Okay.
And a gas giant planet, slightly more massive than Jupiter, was discovered around this star in 2021.
Okay.
Has a buddy.
Yeah, it's got a little baby. A little baby.
How did they discover it?
Well, a 12 billion-year-old baby.
It's an old baby.
Aren't we all?
I don't know. Probably transit method. I don't know.
Yeah.
I didn't read on the discovery of the exoplanet. I just noted that it has one.
I just love how they've discovered all these planets.
Over 6,000 exoplanets.
Oh my god,
it's insane.
I remember being amazed at like 3,000,
yeah.
or like even less than that. Yeah,
and
it was
then
like,
oh god. So I do this thing now in the demos I do with astronomy. But there's one day in 2014, it was a Thursday when Kepler released a lot of the data, and we went from like a couple hundred planets to like 1,400 in a single day.
Wow.
It was a phenomenal day.
Oh my gosh.
So this might be a hangover story, but I worked at an observatory and they had just discovered the first planets, and the first planets were around pulsars,
Mm-hmm.
and I wrote to the astronomers and that had discovered it, and they friggin' wrote back.
Did you keep the leather?
Oh God, it would.
When did you? How old were you? Like, were
Was
you in
this
college?
I was in
was
college,
this
and
88 or 93?
what?
It would be
Wasn't it an
93 if you were in
88 or
college.
93?
It's 88.
88, okay.
Oh,
Yeah, so it was in the 80s, and there was something I had wanted to do with the observatory with regards to it, and I needed to find out some information, so I wrote them. They wrote back, and they were like, "Yeah, you could do that shit." And it turned out that it didn't work out, but there was some photometric stuff that we
That's
wanted to
cool.
do.
You were sciencing.
I was sciencing.
right, astronomers, people. You know what? Most researchers are really happy to share and talk about the research. And if it's like you're doing something where maybe they have like a video or they have a simulation, they have something that it's like, oh, I would like to use this for something. Write to them, because unless it's under like some embargo or whatever, which is usually
Yeah.
just like big NASA stuff.
But it had already been announced, so
yeah,
it was no longer
they're
embargoed.
more than happy to like share your, or if you want like access to a research paper and you're finding online it's behind some bullshit paywall, just email the researchers, because they're usually more than happy to give you the research paper instead of that fucking paywall bullshit that they don't really, it's not for them.
And this was all before email, so I had to like lick a stamp, put it on an envelope, and send
Who
it
does
to
that?
England.
Oh my God,
It went to England.
You had to handwrite an address
I
on
had
an
to
envelope
handwrite it
and
all.
everything. Holy shit! What? Wow.
And so
I don't have my stamps next to me, but
they sent it back in like a manila envelope, and it was just
Sweet.
thick paper.
Yeah.
And I was like, oh, I love life right now.
That's
This
cool.
is so cool.
That's really cool.
Hangover. Okay, remind me of Hangover. I have really cool stamps I can show off.
Of course you do. Of course you do.
Anyway, sorry, continue.
All right. So that's Gamma Pisceum. 7 Pisceum is a red clump giant.
Well, what's the name of it?
7 Pisceum.
7.
7.
We
7
just
of
ran
9.
out of letters.
7 of Pisceum.
Solid. I'll drink to that.
It's a red clump giant, which I was like, I don't know what that fucking means, red clump giant. But it's 343 light years away. It's the second most distant and most luminous star of the circlet, and it has the luminosity of 163 suns.
That's a lot.
Which I thought was cool.
That'll get you a sunburn.
That'll definitely get you a sunburn.
A red clump
giant. I didn't have time to dig in more to it.
That'll give you a 7 Pisceum burn.
Hey.
All right, so this is AI.
Okay.
So take it for what it's worth. The red clump giant is an aging, low to intermediate mass star that has moved past the standard red giant phase.
Okay.
Located on the HR diagram, these stars generate energy by fusing helium into carbon within their cores, typically have a temperature of about 5,000 degrees Kelvin.
Okay, so pretty cool.
Sweet.
Pretty cool in multiple ways. All right, and then the last star I'm talking about, because I thought it was interesting, is Van Manen star, or 2 Van Manen star. It is the closest known solitary white dwarf to the solar system.
Oh, that's cool.
Yeah, it's 14.1 light years away, thought to be around 3 billion years old.
It's like a little baby.
Yeah. Its temperatures determine the age for white dwarfs, because they're radiating away energy. They're no longer making energy. They've gone past that phase. Our sun will eventually turn into a white dwarf as it runs out of fuel, essentially. And so by identifying the temperature of the star, which is a pretty cool white dwarf, it's around 6,110 Kelvin, they can determine then that its age based on its temperature. It was actually discovered in 1917 by a Dutch-American astronomer, Adrian van Manen. It is the third white dwarf identified, or it was the third white dwarf identified. Obviously, we've identified many more white dwarfs out there. But 40 Eridani B and Sirius B were the first white dwarfs discovered. And this one is the first solitary example.
I thought Sirius was. Cool.
Well, Sirius and 40 Eridani, or Sirius might have been first, and then 40. It was the third after.
I just heard.
I'm sorry. It was
Eridani.
It was the third after those two, basically. Okay. But it's the first solitary example. Mm-hmm. But it's not visible with the naked eye, so you can't just go out there and see it when looking at Pisces.
I can. I have elbow
and for the and for the Eridani B, for those of you who have intrepid minds, that is not where Rocky is from. Keep that in mind.
Oh. Which one's Rocky from? He's from the Eridani system, right?
Yeah, but he's not from White Dwarf system.
No.
That much I remember.
All right, there are some deep sky objects in the Pisces area. In fact, November obviously November is the best time to actually do your deep sky observing of Pisces because it's higher later in the evening. But since I'm excited for spooky season to get here, we got some spooks. We got some spooks out there. The first one is M42, the Phantom Galaxy. Ooh. This is a loosely wound spiral galaxy.
Oh.
It's a good thing it's not tightly wound. You don't want it to be too stressed out.
You gotta relax a little bit.
You gotta chill out. It's 30 million light years from Earth. It has many clusters of young stars and associated nebulae. So there's a lot of star formation happening in this galaxy right there. So
nice. It's blue.
And yes, a nice face on.
So why do they call it the Phantom Galaxy?
I don't know, because they're gonna call Galaxy something, and I mean,
it's a pretty galaxy.
It looks phantasmic.
Hey, and what's its actual name again? Like regular name? NGC?
M74. So it's a Messier object.
So we can try to get a picture of it.
We could try to get a picture of it, yes, because we were gifted an astrophotography CCD camera. By a very nice person that we met when we had the telescope out. Yep. So we just have to get a filter wheel, and then we can and a USB cord, and we can start playing around with it. So yay!
And by
me,
because she won't let me touch it.
That's not true. You can play around.
I understand, though, right?
You can play with it. I'm gonna need help. All right, the next spook. The spookiness we got in Spices.
Ooh, a little October spice in there?
Oh my god, I could have had a spicy margarita and called it the Spices.
Next time.
That's good.
Damn. All right.
And we could have put a bubble on it.
I hate it when the puns come too late. All right. Well, this next one is the Flying Ghosts.
Oh, okay.
NGC
I can see that.
520. This is actually not one, but two galaxies that are colliding together.
Oh, love that.
I love it when galaxies collide. This is a pair of colliding galaxies located 105 million light years away, discovered by one of Brandon's faves, astronomer William Herschel.
My man.
1784, December. And so simulations indicate that this object, these two galaxies, it consists of two galactic disks that began interacting about 300 million years ago. And they're still at an early stage in their merger. There's two different velocity systems here, and they have two small tails. So it just shows that it takes a long time for galaxies to
and
merge.
If dinosaurs had telescopes, we could have seen the whole progress happen.
Seen it. Oh my gosh, man!
I was literally just thinking dinosaurs with this.
Yeah, of course. But I just love galaxy mergers, and this would be a merger rather than cannibalism.
That'd be very spooky.
The mergers are the simulations of mergers, and
they're so cool looking.
It's even like in real life, it's basically a slow motion train wreck, right? But in simulations, it's just they're beautiful.
Oh yeah.
And then when you think about the fact that stars are not actually colliding with each other, they're basically just wisps that are passing through each other.
Yeah, because everything's so spread apart that it's just like, I don't know.
It's a gravitational dance of clouds, basically.
Yeah. I was going to say magical, but it's not magical because it's all rooted in science and physics, but it's
all rooted in physics.
I think one of my favorite things, aside from like maybe supernovae and stellar evolution, is definitely like galaxy collisions and cannibalism and
that's a good hangover topic. What's your favorite things besides black holes?
God damn it.
Or anything quantum.
Why hamstring me like this?
All right, one last thing in Pisces is CL0024 plus 17. I don't know. This is a massive galaxy cluster that lenses the galaxy behind it, so you can see gravitational lensing really all over the place around it. So you can see this in the center, that bright cluster, and then you can see these like blue kind of like streaks around it in a circle and elsewhere in the images as well. Everywhere you kind of see that, it's like that is a galaxy behind that cluster of galaxies that is being magnified through gravitational lensing. So we could basically see what's behind the galaxy cluster without being able to actually see what's behind the galaxy
you
cluster.
said there was no magic in physics.
I know. This cluster is primarily made up of yellow elliptical and spiral galaxies. It's about 3.6 billion light years from Earth. And then the galaxy behind it is basically half as far away as I didn't get the full. It's like 5 point something billion away. So it's like, so this is half as far away as the galaxy behind it is from us, if that makes sense. I fucked up my notes.
Warping galaxy is halfway between us and the more distant galaxy.
And the more distant galaxy.
Okay.
Basically, I guess.
And a closer galaxy is probably 5.2 billion light years away.
No, the closer one is 3.6 billion light years from Earth.
Oh, okay. And then so the other one.
So the other one is like 5 something. Okay. Is what I read. So yeah. So I just think this is just I mean, yeah. By the way, in this image, whenever you see this kind of like the cross shape on an object, those are stars within our galaxy, and the cross thing is an artifact effect of telescopes. And so those are stars, but pretty much everything else in this image is our galaxies, basically. And it's just these like deep field type images where you see all these, and you see all the different shapes. You can tell what's spiral, you can tell what's not spiral, and like
it's like looking into the abyss, but even better.
Oh my god, it's amazing. I love this shit. All right, Pisces. So it's got cool stuff in it.
Oh, we're still in Pisces.
Yeah, it's got cool things in it. It's got cool stars.
We're talking about all this other stuff.
You can check it out in the night sky. Again, fall best time, but it will be up, it'll be start rising here in a bit. And we're also a little bit early with our high in the sky for September. So, by September, you can see it in kind of like the later early morning hours. There is a little bit of mythology about it. Our past 2 constellation highlights, we really haven't had any mythology, but Pisces actually has Babylonian origins.
Ooh.
So it originates from a composition of Babylonian constellations, multiple Babylonian constellations, Sinutu, the Great Swallow, which is the current Western Pisces, Enunetum, the Lady of Heaven, and that is where like the northern fish is, so like the other fish. The first millennium BCE texts, known as the Astronomical Diaries, say that this was actually part of a constellation called Dununu, which is the fish cord or ribbon. I'm sorry, but also can we just highlight first millennium BCE astronomical texts from the Babylonians?
We got a shot topic coming up to cover some of that.
Yes. I love that. Okay, so for Greco-Roman stuff, our typical associations with our constellations. There's a couple different versions, of course, but basically associated with Aphrodite and her son Eros, or Venus and Cupid for the Roman version of those gods. The Greek version, according to Hyginus, which, hey, he brushed his teeth.
Nice.
Hyginus basically says that Aphrodite and Eros, while visiting Syria, they fled from the monster Typhon, and they did this by leaping into the Euphrates River and transformed into fishes to get away from him. The Roman variant of the story has Venus and Cupid carried away from the danger on the backs of 2 fish. So they either turned into fish or they rode fish.
The fish, either way.
Fish all the way down.
Fish all the way down.
Fishy story.
Now, there is a different origin story that Hyginus also has in another work. And according to like this other version, an egg rolled into the Euphrates. Some fish nudged it to shore. Doves sat on the egg until Aphrodite hatched out of it.
Oh, that's nice.
And then the fish were rewarded by being placed in the sky as constellations.
That's so nice. Right? And we know what we say about Aphrodite. She's so high above me.
Is this a song reference?
Yes, you'll get it eventually. Mike got it.
Oh my god.
Anyway, let's just keep moving.
Okay, I don't got it. There's some German lore.
Oh,
German
angry,
lore.
Right?
No, it's not angry. They're not angry people. They're just their language just sounds. Their language has harsh angles.
It does.
You know, that's what it is. But this there's this dude Antennete. He owned a tub and a crude cabin, and he met two magical fish. Now, they offered him a wish, a fish wish. He owned a tub and a cabin. Hey, he could bathe, and he had shelter.
I mean, is that like living high life right there? Hey, I own a tub.
Yeah. If you own a tub, that's pretty good.
We own two.
We own two tubs.
Ooh,
we're living the high life. So they offered him a wish, a fish wish. He refused. He was like, no, it's okay. But his wife was like, what? Excuse me, sir. No, we're going to have a wish. And she wished, basically she wanted him to go back to the fish and wish for a beautifully furnished home. So she wanted some better digs, more tubs.
She wants more tubs.
She wants more tubs. So the wish was granted, but she just wasn't satisfied. So then she asked to be queen and have a palace.
Jesus.
And then she asked to become a goddess. Now the fish then were like, you know what, bitch? They got a little angry at her. And they took away all the wishes and gave him back the tub and the cabin for being too greedy, and they weren't happy with her. And so the tub is sometimes seen as the Great Square of Pegasus, which is right by Pisces. So don't get greedy with your wishes, people. Don't get greedy with your wishes.
I just like one wish.
Yeah, I know. Just one is fine. Now, China constellations. There's a lot. They're interesting and very involved. Pisces is several constellations in China. It is Wai Ping outer enclosure, which was a fence that kept a pig farmer from falling into the marshes.
Okay, you
want that. You don't want to fall into the marshes, especially if they're if they're what, Brandon?
They're dead marshes. I see dead things, faces in the water.
There you go. You're welcome. And then
meanwhile, I was thinking, what do they eat when they can't have Hobbit?
See, and then I just think of
the mid-marshes.
Artex. I just think of Artex in the swamps.
No.
Technically, I guess those aren't marshes. Well, kind of.
God, that was.
It's a rough
diabolical.
Go. Artex. Anyway, the marshes were represented by the 4 stars designed 5 Seti, and then the northern fish of Pisces was part of the House of Sandal. CwC. I'm apologizing to all of China for that butchering
a couple
pronunciation.
billion people.
Yeah.
It's fine.
They're not gonna let me in the country now.
It's fine. All right, so that's Pisces. That's a little bit about Pisces, the fish, and the circlet, and some things that are in it. So check it out. Use a star map app on your phone to help you locate it in the sky.
Such a dim constellation, and we spent 40 minutes on it. It's great.
Well, but part of that is our intro.
Yeah, with introduction, 25 minutes tops.
Yeah, I mean, one intro we were just doing 10 minutes of banter before we actually started, so, All right, I'll move on with the rest of the sky. Planets! Mercury, end of September. Visible in the evening sky shortly after sunset or around sunset. Venus, it'll be low in the west-southwest all month. So Venus is your prime planet to see.
If you have good horizons.
Looking at
you, Iowa.
Because they have good horizons, because they got nothing on them, but they're just flat. Yeah. Mars will be high in the east before sunrise in September. Jupiter, early morning sky is when it makes its reappearance. It's not currently visible. Saturn will rise in the evening well after sunset. By the end of September, it'll rise at sunset.
Okay.
And then Uranus and Neptune. Neptune will be in opposition on September 25th, so that will actually be the best time to view Neptune, but you will need binoculars or a telescope because it's Neptune and it's far away and doesn't reflect a lot of sunlight back at us, so can't see it as well with our eyeballs without help.
There you go.
Yeah. There are a few events happening in September, some celestial events, that is. On 9/11, it will be the new moon.
Okay.
So, great time to look at the night sky and stuff, because no moon is good moon.
I have a question. I'm so sorry to break your flow, but I
Yes.
need to know this from Jack. So Jack in chat says, we have fog in the evenings from all the corn-based humidity. Corn sweat is real this time of year. Is that a thing?
Corn-based humidity?
What?
Is that in like your weather reports? Do the weather people on TV talk about your corn humidity?
I think we let him respond and continue on.
I know, there's gonna be
100% chance of corn sweat tonight?
100% chance of corn sweat. Well, folks, the corn humidity this evening is going to be in about 20%, so...
That corn be popping today.
Oh, yes. Corn be wild. I do love some corn, though.
Oh, yeah.
Corn is good.
You got the biggest bag of popcorn.
Yeah. I said, my response to Brandon's text image of that was, that's what dreams are made of. Because I love a big bag of popcorn like that. And Scarlett in the image was just like eyeing that popcorn. Like, did she get it?
She knows what's up. Oh yeah.
Of course she did. Yeah. We made popcorn last night. We decided to watch Mandalorian and Grogu and movie, which was fun. It was fun.
Okay, that's all I asked for.
It was fun.
That's all I asked for.
That's all you need, just to have fun with it. And so I made some popcorn because I was like, I have to have some popcorn now. So good. I want that bag of popcorn. Anyway, it looks like good popcorn, like good butteriness to it. Anyway, okay. So the new moon on 9/11, 9/23, September 23rd. Guess what, everybody? Welcome to fall.
That's 1 month away.
1 month away. The fall equinox. And we're finally hitting
September 23rd?
September 23rd. We're hitting it. We're getting there. We're Halloween right around the corner. I'm excited for it, for that candy corn humidity.
Right now, I would just be happy.
I'll get the candy corn sweats.
If the nights were longer than the days.
Okay, Jack has responded in chat. He says, plant transpiration is when the corn and beans release the moisture from photosynthesis. It really ups their humidity, currently about 80%.
Wow.
What? That's wild.
That's so cool. I didn't know that fact about corn.
I did not know that.
There's clearly much we have to learn about corn.
Yes, the things you know in the Midwest that you don't learn anywhere else in the country.
But with that humidity, though, I couldn't live there.
Yeah, that's a lot of humidity.
My hair would get curly.
Katie says she can't wait for sweater season, and I am with you, Katie. I am with you. Okay, we got some more events here. On September 6th, I put these dates out of order. September 6th is the full moon.
And it doesn't matter. Roll with it.
So, whatever. And then, sometime in September, I don't have an exact date for you, but sometime in September, JUICE, Jupiter Icy Moons Explorer, will do its first 2 flybys of Earth for a gravity boost.
I'm assuming this is the first of 2?
First of 2. Yeah, okay. Apologies. First
you
of 2.
Say first, though.
Yeah. Fist 2 flybys.
Fistinger.
Welcome to Cosmos with the Cosmos.
Our first of 2 flybys of Earth for a gravity boost. So basically, the spacecraft that's heading to Europa? JUICE?
Yeah,
Icy
JUICE
moons?
is Europa.
It basically is going to use Earth like a slingshot to help catapult it, to help speed it up.
It's slow us down.
It's using Earth and Venus, I believe, though, for a gravity boost. So I think Earth might be first, and then it's doing Venus.
Oh, that makes sense.
So it's going to be like, so it's getting slingshotted twice to get there and help it get there faster.
Yay, physics.
Yay, physics.
Yay, Newton.
That's how
we're going to do the old shake and bake.
Woo! All right, this month in astronomy history, September, astronomy history. September 3rd will be the 50th anniversary of Viking 2 landing on Mars.
Hey.
Go Viking. Yay. So all Vikings fans should celebrate Viking
Skull!
landing.
That's what they say.
Skull! On September 23rd, which is also the fall equinox, it will be the 180th anniversary of Neptune's discovery.
Oh.
Johann Galle spotted it after some math predictions by Urbain Le Verrier, because Uranus, which was discovered like 60-something years prior, wasn't behaving correctly. It wasn't orbiting in a predicted pattern, and they realized there was something large out there tugging on Uranus. Insert any
we
joke
pronounced
you
it
want
correctly,
right
so
here.
there's no joke.
And so they did some math. And then he was like, hey, I did the math. You go point a telescope up there. And Johann was like, all right. And he pointed his telescope up and boom, Neptune.
Yeah, he found it that night.
Planet, right there, right where the math said it would be.
Can you imagine, like, oh, I found it. My night's
like,
done.
Hold on, let me just do a little math. Okay, right there, dude. Oh, we got it.
Yeah.
Let's go to bed now. High five. And that's how we got Neptune.
Yay, team.
Can you believe it? Okay. Solar system, our solar system, the planets in our solar system. We have not known about all the planets in our solar system. We've only known about all the planets in our solar system for less than 200 years.
And we may or may not still not know of all of them.
Yeah, there could be more we don't know about.
A little more than 200 years, right? But
well, 180 for Neptune.
We'll say 250.
So
we have discovered everything past
I see
Jupiter.
what you're saying. Yes.
I mean everything past Saturn since 1776, the Declaration of Independence. As long as this country has existed, we have discovered these outer planets.
That's and then think about the history, the time frame that humans have existed for with eyeballs.
Right.
And with eyeballs is the important part in that, because we've existed without eyeballs for a while, but now that we have with eyeballs,
game changer. That and thumbs.
But
yeah.
But what's also crazy is it's like what Brandon was talking about with exoplanets earlier, where like in one day it goes from like 4 exoplanets to 1,400. But it's like that. So Uranus, Neptune, we got some asteroids in there, and then
Pluto.
Then we explode. In the past 100 years, the inventory that we've added to the solar system has exploded.
One might call this the golden age of exploration.
Yeah, or the horse and buggy days.
About a decade ago, but yeah.
This also I saw this online, so this isn't an original, but I'm readapting it and paraphrasing it. But it's like so this is an argument that you can use for the vaccines cause autism people, because it's like, oh, cases of autism in X years prior, limited, and now cases of autism and exploded, so vaccines cause autism. Okay, then that means telescopes responsible for exoplanets by that logic. So
facts. I don't see the issue here.
So
the telescopes cause exoplanets.
Since I have been alive, we've discovered thousands of exoplanets. So I would actually posit that
you cause exoplanets.
I am responsible for exoplanets.
Brandon causes exoplanets.
But you weren't alive the first exoplanets we discovered. But I do have a question for autism. If autism was around prior to vaccines, what caused it before vaccine?
Washing your hands, germ theory.
It only was caused by vaccines because it wasn't around beforehand. Apparently, that's the argument. Anyway.
I do love the little meme of, oh yeah, your grandparents didn't have autism, and meanwhile cuts to your grandpa who had like 2 levels of model trains.
It's like,
you're right.
Okay. All right, well, that is the night sky for September and the celestial events that are upcoming for September. So
check it out.
Get excited. Observe some shit. Appreciate.
Tweet us the pictures you take of the sky.
Yeah, we want to. Send us messages. Ask us questions. We're here
join your local astronomy club.
Yeah, go to your local planetarium. Unless it's in Phoenix, then go to like Flagstaff or Mesa. Because they don't do space shit anyway, really. It's time now for Astronomy news, September 2026. Well, it's before September because we're doing the astronomy news that came out now, which is still August. Okay.
Still be true in September.
I got some fun topics and I got a lot of topics, and we got some pictures.
So we're gonna lock in.
We're locking in.
The topics never ended. Well, I actually stopped looking at the notes.
What did I just say?
I pulled earlier, and then I wasn't finding a lot, but then in the past, few days, a bunch came out that I was like, oh, shit.
We're going to give Liz the mic and back the fuck up.
So, first one, astronomy news, black hole star, which then I immediately thought Soundgarden, of course. Astronomers discover a brand new type of astrophysical object. What? MIT, so a bunch of fucking smart people.
Assholes.
They found a super bright red object that looks like a huge star, size of our solar system. Would be a really fucking... I mean, there are stars that are larger than our solar system, so yeah. Size of our solar system, 100 billion times more energy than any known star can produce. Closer to the energy produced by a black hole.
There we go.
So we have a new type of star suggested, a black hole star. Like, what the fuck? What?
Obviously, artist.
Yeah, artist rendition on this image right here. This was discovered by James Webb Space Telescope. Classic James Webb material here. It was spotted a few 100 million years after the Big Bang. And it's basically a mashup of a black hole and a star. It's a huge, dense cloud of gas that's powered by a black hole.
Okay.
So black hole star. Rohan Naidu, we won't drink to that because I still have the image up. A NASA Hubble Fellow and Pappalardo Fellow at MIT's Kavli Institute for Astrophysics and Space Research says, we think there is a central black hole that is 100,000 times as massive as the sun. And around this black hole, there would be this very extended envelope of gas that looks like a star the size of the solar system. It's huge.
It does look like a Georgia O'Keeffe painting, Elizabeth says
in
chat. It looks like a Georgia O'Keeffe painting.
I'm not good with art, so...
The answer is yes.
Okay. So basically this would help solve the identity of other mysterious little red dots that have appeared in nearly every deep space image by James Webb.
Oh, that's cool.
Which is kind of an exciting prospect.
Yeah.
According to the researchers, these little red dots seem to be everywhere in the early universe, but essentially disappear by the present day. What exactly these objects are has been one of the most debated topics of the JWST era. We're in the James Webb Space Telescope era, people.
We were in the Hubble era.
Now we're in the James Webb era.
Yeah.
They were looking for the most distant, earliest galaxies as part of a survey they named Mirage or Miracle. Take a guess, folks. Come on down. Mirage or Miracle. Parentheses, Mom.
Never mind. I had a really good joke right there. I'm going to pull back from the...
Okay. Naidu says there's been this puzzle of many bright galaxies showing up at the extremely early times, and what we found was that what looks like an extremely bright early galaxy, also known as a miracle, in some cases actually could be a mirage. So not what they think that it looks like. Every little red dot is consistent with being a black hole star embedded in a generic early galaxy. But what is special about Mom BH1, which is this black hole star 1, first black hole star, is the black hole star is essentially completely outshining its surrounding host galaxy, such that we're seeing pure black hole starlight. Black hole starlight. It's like the theme of this show is magical. That's the most magical thing I've ever heard. Black hole starlight. And also it's like
there was a Jeopardy question in which they referred to Gandalf as the magical man. So yeah.
He is a magical man, and his fireworks.
Yes.
Black hole starlight. I'm obsessed with this. Black hole star. Someone needs to recover Black Hole Sun now.
But
someone with musical talent.
Is Soundgarden still alive? I mean, could they do that?
Well, Chris Cornell isn't.
Chris Cornell's not.
See, I don't know. That's why I ask these questions.
To me, you can't have a true Soundgarden.
Sound
somebody
get
Weird Al on the phone.
Somebody get.
Well, we'll see him in a couple weeks.
How to resurrect the dead. No.
All right. Black hole starlight. I need more information on black hole starlight. Obviously, so
I have a paper
this energy from the gas that it's illuminating around the black hole.
The gas gets the energy from the black hole, which then
yeah. So there you go. All right. So that was fun. No AI. No, I get Muse to do it.
Well, they did have that. When I was getting my tattoo, Muse came on twice, but one was their black hole song, and I was like, all right, I can.
Oh, they have we were hangover. Focus. We're focusing.
Locking in.
Next article. Einstein probe catches rare X-ray flash from an exploding star.
Okay. Please tell the story about the Einstein plant. It can be It can be in The Hangover, but
Hangover.
Oh, okay. Hangover. Remind me in case I forget. Right. Einstein plant.
Probe.
Hangover.
Einstein probe.
So, researchers have linked an X-ray flash discovered by the Einstein probe to a known type of supernova with unusual features that point to the birth of an ultra-dense, rapidly spinning magnetar.
Ooh.
So, star explodes. Magnetar formed from the...
Who was the first person to introduce you to Magnetar?
Nirvana.
Mm-hmm.
Yeah, I love the Pokemon.
Is there a Pokemon named Magnetar?
There is.
I was past the Pokemon. Anyway. Category events called extragalactic fast X-ray transients, or EFXTs. They are brief flashes of X-rays lasting minutes to hours whose origins are still poorly understood. There's a rarer subset, though, called X-ray flashes, which some research think they originate from a completely different type of dying star, and a few of them have been directly linked to a visible counterpart, aka supernova. Which is what happened here. So most space telescopes, they're built to monitor bursts of gamma rays and not lower energy X-rays. X-rays are more difficult to find. But the Einstein probe satellite, it was built to hunt faint X-ray signals, so it is a genius. Just like its namesakes. And we saw slices of Einstein's brain at the Mutter Museum in Philadelphia. So I recommend the Mutter Museum in Philadelphia.
If you happen to be in the neighborhood.
And if you're not squeamish.
And he didn't give the okay to do that, right?
No, don't make us feel bad about it.
Not you guys.
Oh, Einstein.
Einstein.
It was a physician's college, so it was for research. It was a legitimate.
Anyway,
place.
We saw
slices of his brain.
Anyway, continue.
Okay. Goku P. Oh boy.
Goku P.
Anyway. Goku P.
Something.
S of the University of Maryland analyzed an X-ray flash that has a ridiculous name and its supernova counterpart to determine the physical mechanism behind the explosion. And so rather than triggering as an obvious bright signal, it appeared as a faint borderline detection in the Einstein probe's data, but they needed extra help to confirm this.
That is a tough name.
Yeah, this name. Okay, I'm going to go for this name because I feel like he just deals with mispronunciations all the time. So I don't feel that bad. Srinivasaregavan.
Solid.
There you go. Holy shit. Imagine trying to learn how to write that as a child. Anyway, so the confirmation for this, so Einstein probe initially spotted it, and then they used confirmation from a separate project, which was the Zwicky Transit Facility.
Hey, amaze.
This is a ground-based telescope that scans the same patches of sky as the Einstein probe, and it's looking for matching flashes of visible light.
Okay.
All right, so it's confirming, basically saying like, oh, you saw that? Hey, guess what? I saw the same thing right here too at the same time. So it confirms it. It spotted a new optical transients, hashtags, parentheses, supernova, in the same location 5.5 hours after the X-ray flash, confirming the X-ray signal as genuine, basically. The supernova data, it showed no hydrogen or helium. So, combined with signatures of extremely fast-moving debris, it was consistent with a type ICBL supernova, which the same violent envelope stripped category linked to previous X-ray flashes. Early spectra also showed ejecta racing outward at roughly 25,000 miles per second.
Oh.
It's fast-moving stuff in a supernova when a supernova happens.
Go around the Earth once. Roughly.
Wow. So after the explosion's initial brightness peak, most supernovae fade in a very predictable way. But instead, this one, instead of declining smoothly, its total energy output flattened for about 20 days, which is the first time this has been seen of this kind of like extended plateau in one of these X-ray flash supernovas. And so the explanation that fit this was most likely a newborn magnetar, which is an ultra-dense neutron star with a super powerful magnetic field, spinning several hundred times per second, and then slowly transferring that energy into the expanding debris. A rare X-ray flash was produced when a massive star's core collapsed under gravity and then leaving behind the powerful magnetar.
That's cool.
Cool.
So yay!
All right.
This is how space science works.
Mm-hmm.
You get one telescope sees one thing, and then another telescope, yep, I saw it
There
too.
it is.
If one telescope sees something, that doesn't mean shit.
What was it? Maybe it was a decade ago by now. I think there was a observatory instrument in Italy that saw a particle move faster than light that was like briefly corroborated by a different facility. Do you remember this?
I do not.
I vaguely remember this, but that's a hangover topic.
Corroboration is important. It's like the Crab Nebula, where Chinese astronomers recorded the event, and we can also the Anasazi, which I don't think that's the appropriate name for them now. There are basically cave drawings of the same event that are at the same time, and so they can corroborate those two data points from completely different civilizations across the world as witnessing the same event.
Yeah, and a more modern example would be fast radio burst, where FRBs, where for a bit an observatory in Australia were the only ones who saw it.
Just the Aussies.
It was like, the Aussies. They saw a couple, and nobody else saw them, and so then it's like, hey, is this an issue with the observatory? Mm-hmm. Is this in the data? What have you? But then I think somewhere in China saw another one, and so,
then it helped confirm that they're legit. That's what science is. You need to have different data points.
I vaguely remember this.
In a chat, Brandon put in chat, since chat's not visible on this right now. Okay. All right. Well, we don't need to know about the Einstein
In 2011, the Opera collaboration reported that subatomic particles called neutrinos traveled 730 kilometers, 60 nanoseconds faster than light. However, it turns out this was resulted to be an error caused by a loose fiber optic cable in the timing system. And in our line of work, you know plenty about loose fiber optic cables.
Yeah. And that line of work is the Planetarium field. Hubble's still going strong in the JWST era. Hubble reveals that star formation is slowing down in the Andromeda Galaxy, our nearest, largest galactic neighbor. The Andromeda Galaxy. We are the Milky Way, and I say we as in the Milky Way, is consuming two small galaxies, large and small Magellanic Clouds. You can see them in the southern hemisphere, or cannibalizing them. They must taste yummy.
So this is just verification of something that was already assumed, right?
Was it assumed?
Yeah,
Let's find out.
like the peak star forming time was well in the past.
Oh, okay. Well, I guess this is confirming them.
That's pretty much
so
for everywhere.
Andromeda, our largest nearest neighbor, although it's heading towards us and it's going to collide, we're going to have a galactic collision with Andromeda, which then will spawn a burst of star formation.
It will. Yes, it will.
So that's exciting in about, a couple billion years or so, which we're fucked anyway. Andromeda, the galaxy, allows astronomers to better understand the evolution of our own galaxy. It's very similar to our galaxy. It's slightly bigger than our galaxy, but not like by too much. So it's close enough we can get a good view of it, good observations of it. So studies using data from 2 studies conducted by the Hubble Space Telescope, which is still going strong, still very important in our scientific study of the universe. Researchers at the University of Washington partnered or combined data from the Panchromatic Hubble Andromeda Treasury, or FAT.
Hell yeah.
It's PH FAT.
Yeah.
And the Panchromatic Hubble Andromeda Southern Treasury. It's FAST. PH FAST, just like fancy physics punk. Over here, for this study, and they show that star formation in the Andromeda galaxy is winding down. Star formation has been in decline over the past 500 million years, but there's been a steeper drop in the last 40 million years. They calculated the rate of star formation using the mass of gas and dust converted into stars per year. So basically the amount of mass and dust a galaxy has, then they do some math to convert that into, hey, here's how many stars per year that mass and dust can make, I guess. And so the surveys, those 2 FAT and FAST surveys, they mapped out about 2/3 of Andromeda's disk in extreme detail, providing a detailed look into its past activity. I didn't get who said this. Oh no. Study co-author Ben Williams. He says, we need to measure the individual stars, which is what they did, because they are the fossil record of the galaxy's formation. Hubble is the only telescope that can give you high enough spatial resolution over a large enough area to be able to do that in Andromeda.
Nice.
So they had to actually measure individual stars for this. And I remember this was in, it was before we left the planetarium, and it was that most high res image of Andromeda to date. And I remember pulling that up on the dome and explaining, okay, you see what looks like graininess in here? Like it's almost low res. Those are stars. Like those are not just low res grain and whatever in an image. Like those are stars. It was just the most amazing image, especially to put up on a dome. So the research team calculated that 500 million years ago, Andromeda formed stars at a rate of about 1 solar mass per year.
That's not bad.
Which fell to about half that by 40 million years ago. The current rate has declined to about 1/5 of a solar mass per year.
Okay.
So, sharp decline. And they noted that this decrease is driven, or is from decreasing activity within the ring structure of the galaxy. They hypothesized that this is just like a natural process, a natural winding down from a previously more active state, rather than a result of reduced material for new stars. So, it has material for new stars.
Right, but every time you create a star, you reduce the amount of material to make stars.
So it's just winding down. It's aging.
It's just winding down.
We're like the Roman Empire in 400 BCE or ACE. Past our prime, winding down.
I'm getting tired.
He said that in a very Bill Clinton kind of.
He did
sound.
actually have a little bit.
I was thinking about Little Rock in my head, so that's where I'm at.
I couldn't find this guy's first name. Wayner is his last name. Wayner.
Good save.
We can't explicitly say that we're seeing a decrease in star formation because of M42, which is another galaxy that they thought might be attributed to being close to Andromeda. It might be affecting it for some reason, but that it is a suspect that this other galaxy, 16,000 light years away from Andromeda, may have interacted with Andromeda. And it has caused some of that decline in star formation.
And
Go.
At the same time, though, yes, maybe it was this M32 causing this decline in star formation. But at the same time, throughout the universe, I can't remember where the astronomer has this line, but 95% of all stars to ever exist have already been born.
Yeah, that's...
Yeah, that
if you want an existential crisis,
that's it.
So, yeah, that's what I was referring to earlier when I said, but this is like a known thing, right?
Oh, okay.
Yeah,
because like the peak was billions of years ago in star formation
is declining,
and that peak is like when they say that peak, it's universe wide, so it's not just like
so this is kind of confirmed.
But that also means that our sun is peak.
No, that's not what it means.
I know, but let me have it.
But good news, the Nancy Roman Grace telescope will help us learn even more about this evolution of galactic star formation. So, yay, that telescope that's coming online. Working towards it. All right, another first for the James Webb Space Telescope, because we're in the James Webb era.
We are in the James Webb era.
It detects three, not two, not one, but three supermassive black holes in the same fucking galaxy.
Wow. Okay, so collisions.
That's
same
intense.
Galaxy with three supermassive black holes. That's a lot. Here's an image of that. Now the dots of the black holes in this image are not to scale, but just highlighting kind of where the black holes are being observed here.
So it doesn't correspond to mass, though.
I don't know what that means, but let me go ahead and get
like
into
the bigger the circle, the more massive.
I'm not sure. It did not say that in the description of the image. But not to scale. I just assumed like size, but I guess maybe mass-wise. So this new discovery is bolstering the idea that mergers are behind the evolution and growth of supermassive black holes. So galactic mergers are behind the evolution and development of supermassive black holes. So this is the first time that we have found three actively accreting black holes in a single galaxy.
I mean, can you imagine the gravitational waves that are going to come off of this thing?
Oh.
Because they're orbiting each other now.
Yeah.
Those two that were very close to each other, and they're going to start just whirling around each other. And those are going to make some big-ass waves. Yeah. How far away is that?
We'll get there.
Okay.
12.5 billion light years.
Oh, all right. Well,
it's far enough away. It's far enough away that we're not going to feel shit. That maybe LIGO will get a little something from it, but it's not going to be disastrous for us or in any way. The lead author of this paper... I mean,
to be fair, I was not thinking that.
Okay. I just immediately went to our demise. Yeah. That's just how the world is now. Lead author is Hannah Ubler from the Max Planck Institute for Extraterrestrial Physics, which, by the way, extraterrestrial physics...
that's most physics, right?
Yeah.
Because it means outside of the Earth, but also any normal person that hears the word extraterrestrial immediately thinks aliens. It's not aliens. It just means physics outside from the Earth, outside of our solar system.
Yeah, but...
What? Wait.
Hold okay.
Okay, but
I have thoughts.
Okay, but can I get to
yes.
This is...
Yes, you can.
Okay. They used this... The project is called... Black Thunder. One word.
That's like something Captain Holt would call himself.
Black Thunder, which stands for black holes in the early universe and their dense surroundings. Black Thunder.
Fuck yeah! That goes hard.
That's
so cool.
This isn't even an initialism. It's basically just like whatever. Naming done fun in research papers.
It sounds like a stripper.
Yeah.
Evidence. So the paper is titled "Black Thunder: Evidence of 3 massive black holes in a Z." The approximate sign 5 galaxy. So again, 12.5 billion light years away. This happened 1.2 billion years after the Big Bang. The solar masses of these black holes are 80 million, 0.6 million, and 2 million. The first two are the closest together. So the 80 million one and the 0.6 million mass black holes are the closest together. The third is more distant. The 2 of the 3 of the black holes are in the center of the galaxy, so that would be the 2 most closest together ones. They're only about 620 light years apart, which is pretty close. The third one is in the outer region of the galaxy, about 5,500 light years from the center.
Okay.
So according to Hannah Ubler, it suggests that the processes in the early universe were efficient at bringing massive black holes together, setting the stage for the massive black hole mergers we expect to detect with future gravitational wave observatories.
Cool.
Mm-hmm. The closest pair of black holes will likely merge soon.
Yep.
The outlying black hole is slowly approaching the center. It will eventually merge.
They've already merged.
They probably have already merged, yeah. For the closest pair, it will take approximately 700 million years for them to merge.
They've already merged.
They've probably already
They've
merged.
all merged.
They've all merged together at this point. So many researchers have suspected that galaxies with multiple black hole systems weren't rare, and that these mergers played a big role in the supermassive black holes that we see today. And this is now evidence that, yeah, these things existed, and that, you know, so it's exciting that this is the first time that we've seen this, and is probably not going to be the last time.
Nope.
Because this is responsible for our supermassive black holes that we see today in the center of galaxies.
How many more we got?
We got a lot. Get ready. Hold on to your butts. We're fine.
Lock it in.
No, we're okay.
We're fine. All right. NASA calls off the mission to rescue the Swift Gamma Ray Observatory. There was a mission. I didn't know about. We had a mission between NASA and the Catalyst Space Technologies. They built this refrigerator-sized spacecraft that was going to go to the Swift telescope observatory. It had robotic arms, and it was basically going to like push it to a higher orbit so Swift didn't basically burn up in our atmosphere.
Yeah,
is what it was going to do. Now normally these like any kind of like satellite or whatever takes like years to create. They had 9 months. 9 months to make this satellite for this rescue mission. NASA awarded Catalyst a $30 million contract for this rescue operation. Now, NASA Administrator Jared Isaacman, he says NASA should be willing to move quickly and take smart risks. It's not a small risk. Smart risks when the potential return is worth it. And that's exactly what we did with this mission.
So why did they cancel it?
So 2 of the satellite's 3 reaction wheels that were going to be used for attitude control stopped working. So it's basically unable to complete the mission because of this.
So there was no like political reason.
There's no political reason. It wasn't canceled just because of funding or whatever. The money had already been paid. It's because, unfortunately, things broke on it. And it could be due to how rushed it was of a mission, and corners were cut and whatever. But it was a good kind of like experiment, if you will, in like a rush job to rescue.
Right, and I also think that in today's political environment, that the distinction between it was not a political decision,
is
that
important.
It was a physical distinction is important.
Yeah, that makes sense. Now, these type of missions, though, could be important. Like, quickly building a spacecraft that can go and save another spacecraft. That means you can, like, refuel, repair, upgrade satellites, and so like the technologies that were made, like the robotic arms that were developed for this satellite, for this mission, could be very important for future missions of like servicing satellites. So it was like an attempt to service a satellite. It unfortunately didn't work for various factors. But at least it was a good try. At least something was done to try and test some technology and develop new technology. So we'll see if we can do something in the future that is successful, rather than letting a good observatory like Swift, which I think it had some issues with its like, I don't know, it had some issue that has caused it to prematurely end. I forgot to write down what it was. On other news, in terms of not fixing spacecrafts, how about just slamming stuff into the moon?
Why not?
SpaceX rocket slammed into the moon, and the Lunar Reconnaissance Orbiter spotted its lunar grave, so to speak. So here's the crash site. On the moon, the LRO, it was a Falcon 9 upper stage rocket. It slammed into the moon near the Einstein crater at 5,400 miles per hour. Oh, no, that's the wrong picture. Sorry. There we go. Here's a gif of it.
That's cool that you made that crater.
Yeah, so you can see the new crater form. You can see those ejecta rays from it as well. The newly formed crater is 60 feet wide and appears to be about less than 10 feet deep.
And reports hold that there were no tardigrades on board.
No tardigrades, but there might have been some tardigrades impacted.
That we know of.
Some tardigrades may have been impacted.
But yeah, all those tardigrades were like, "This is war!" And they're going to shoot like little tardigrade missiles at us.
For more on that, look at the book "The Moon is a Harsh Mistress."
The moon is a harsh mistress. By.
Who starts the H?
Okay. Google "Moon is a Harsh Mistress" by H.
Damn it! I'm gonna find out.
Okay. In other news, that was just a fun one. I just wanted to show like the GIF really of the new crater. That's really kind of all I wanted to do.
Yep.
With that. In other news, in feminist news, Sophie Adenoir became the first French woman to spacewalk.
Oh, that's cool.
Yeah, I apologize for mispronouncing her name because I'm not French and I don't know how French accents work. But Adenoir became the first French woman and fifth French citizen to perform a spacewalk. And the second European woman to do so after Samantha Cristoforetti in 2022.
Have that crossed off already.
So the task was...
Yeah, I don't know.
The task was to, it was a swap. It was to remove a failed space-to-ground antenna and bolt a fresh one to the station Z1 truss. Basically, the antenna stopped being able to track NASA's data relay satellites, which is what a space-to-ground antenna does, basically. Now, however, they ran out of time in this mission. They were budgeted for like 6 hours and something to complete the work. However, operating in space doing maintenance in space is hard. You got thick gloves, you got all this bolts, all this stuff, no microgravity basically happening. So they were able to get the antenna off, and there was some other dude that went out with her on the spacewalk. We don't give a shit. They were able to get the antenna off, but they weren't able to replace it with the new one yet. Mission Control, since they were over the time allotted for the mission, NASA Control basically said, hey, secure everything and come on back. And we'll schedule another walk to then put the new antenna on. So they basically just needed more time to finish the job, which shows that maintenance in space is just the same as maintenance on Earth, except for, less gravity, and space is actively trying to kill you at all times. So slightly ups the difficulty level.
And the other astronaut, Anil Menon, was born to Ukrainian Indian immigrants in Minneapolis.
Hey, there you go.
So American citizen?
Yeah. Born in Minneapolis.
So immigration is important, guys.
Immigration is important. But also congrats, Sophie Adina, on your first historic spacewalk. Yay. Fun stuff. Some fun stuff. All right, here you go. This is for you. Are you ready for it?
Let's do it.
Quantum entanglement generated from sunlight for the first time ever.
I think that's cool.
How do you feel? You like this?
Yeah, so
you think it's cool?
Quantum, which apparently I'm not allowed to think is the greatest thing ever.
You can think it's the greatest thing. You just need to have other things that you share.
Because dogs exist, so quantum can't be the greatest thing ever.
True.
Well, okay, that is fair and true.
Very fair point.
That is fair and true.
Dogs greater than quantum. Entanglement. So two particles that are inextricably linked when measured.
Yeah,
it's
so
like us. Are we quantum entangled?
Nice. Aww.
So gross. Anyway, so you change one, it instantly changes the other.
That's wild.
Which
spooky
action at a distance. Nobody liked that shit. Yeah, so
it's brain melting.
Yeah, so basically Einstein's like, I don't like this spooky action at a distance thing. And so you change one property and it immediately changes the other. And this actually happens. It changes faster than, so the crazy part is nothing can go faster than the speed of light, right? That includes information.
Mm-hmm.
And it's like somehow this particle knows that something has happened to this other particle, and it knows it instantaneously, which means that information, quote unquote, got to it faster than the speed of light. And that's the craziest part of it.
And that's the second thing that can travel faster than the speed of light. The first thing is the speed of love.
Oh.
And I broke Mike. All right, what's going on?
Oh, that's cute. Okay, so this has potentials for advancements in computing technology, communication, sensing technology. So this is applicable.
Oh yeah, I forgot. It was the sun. Sun did this.
Applicable for technologies we use on Earth by using quantum entanglement for things, which is wild that we can use quantum entanglement for things. So the standard way, the basic way of entangling photons is to fire a high energy laser, of course, into a specially configured crystal. Sure, laser beams at crystals, obviously, entangling photons. Cool. Run-of-the-mill quantum entanglement. Run-of-the-mill.
Just run-of-the-mill.
Run-of-the-mill. So researchers from the University of Ottawa in Canada and the Max Planck Institute for Science of Light in Germany generated entangled photons from sunlight. So when you're entangling photons...
I don't think there's anything wrong with Max.
Because it's Planck, Max.
Well, I think
or it's the most Planck, so it's the Max Planck.
It's the Max Planck.
But anyway, I'm sorry. Continue. I think either way.
So when you're entangling protons, you need a high amount of energy. And what has a great amount of energy? The sun. The sun has a shit ton of energy. It has a literally brain melting amount of energy. Yeah. Literally. So the team of this research says that the innovation could lead to entanglement technology that's cheaper and easier to deploy in resource-restricted environments like remote resource stations on satellites in orbit and stuff where you don't have access, where you can't put a high-energy laser on, unless you're, Dr. Evil. Lasers. That was
$1 million.
I'll take that.
So there were earlier experiments showing that entangled photons could be produced by LED light, suggesting that incoherent light.
LED light?
Also,
can we get
Nope. Let's not do that.
So incoherent light, which is not drunk light, but light without synchronicity and uniformity of lasers has the potential for triggering this process. So what they did was they used a window-sized Fresnel lens. I don't know what that is.
The Fresnel lenses are like the ones they use in lighthouses. Special kind of lens. Makes it very bright. Very bright.
Oh, that's cool. All right. And then they funneled a concentrated amount of sunlight into an optical fiber that was the width of a human hair.
Oh.
They funneled sunlight into a fiber a width of a human hair. I should have picked one of my gray ones. You could see it better.
The power of the sun.
Power of the sun. And then that focus light was then shown onto a crystal to do the actual entangling of it. Yeah.
So
I'm already like, I don't know what's happening.
Well, no, I mean, you could just take light from the sun.
Light from the sun.
And
into a fucking beam the size of a hair at a crystal.
Well, you do need that Fresnel.
With that special lens.
Yeah, lens.
Which are cool lighthouse lens.
But yeah, I mean, that's like, it is super cool.
Now they focused on the polarization of the sunlight to address kind of this messy characteristics of sunlight. So they polarizing it. So they use like polarization, whatever the fuck that means. The particles were about 94% similar to a perfectly entangled state, and they violated Bell's inequality. Bell's inequality, take it away, fancy physics punk.
I don't remember Bell's inequality.
I put you specifically in the notes.
Okay, it says to sum it up, a standard sign that the correlations cannot be explained by classical properties.
Oh, okay. There you go. All right. Well, let me find it
from the notes.
I follow along. Thank you very much. It's like popcorn back in grade school. Just in case I get called upon, I like to make sure I'm following along.
Well, I don't think I was participating in that.
Anyway, I'm looking something up. All right, go ahead.
Okay, you look it up. So, once the entangled photons are created, they can retain their intrinsic link even when separated by enormous distances, which means that linking giant telescopes or communications that can't be like intercepted. Linking things that are really distant apart. You can do encrypted like stuff, so you can't have people intercept them. Okay, so this whole experiment, this is a proof of principle demonstration. There's no sunlight powered quantum entangler yet that's made that can be like used by anybody, that can be shipped around the world, that can be packaged into technology. This was basically the first test that sunlight can be used to entangle photons and use them for fucking crazy ass technology that we're developing.
Right.
Yeah. So there you go.
Sunlight powers everything.
Cool.
Or can.
It can. I mean, sunlight is. I mean,
it's energy.
It's energy. It's all energy. It's
the closest. Is made of energy.
It's the closest, most immense form of energy that we have. Sunlight.
Well, besides Leia.
Besides Leia and her fucking grass farts. Oh my god. But I mean, and the fact that we don't utilize sunlight more is insane to me. Absolutely insane that we don't utilize sunlight for fucking all of our energy needs.
It's more on that fossil fuel lobby.
Oh my god.
Anyway, continue.
Right, time for pretty pictures. It's the pretty pictures segment of the show. Hey. Pretty pictures. Webb captures the clearest image yet of the Lion Nebula. Ooh.
Oh, isn't it the Eskimo Nebula?
It can also be the Eskimo Nebula, I think. It's NGC 2392, known as the Lion Nebula. It's about 5,000 light years from Earth, but estimates vary between like over 3,000 to 6,000 light years from Earth.
When does James Earl Jones speak to us?
This image, you can see like the very complex structure, the white dwarf at the center. You can clearly see that.
Yes,
and
they are.
It is also the Eskimo Nebula or the Inuit Nebula, because Eskimo, I think, is derogatory now.
Well, but I think it's officially called
So, but we'll call it the Lion Nebula because it resembles the mane of a lion around this kind of central white dwarf. That central star is so hot, it's illuminating everything inside the bubble, ionizing hydrogen, causing it to expand and destroy the dust it encounters. Astronomers estimate that this sort of like appearance of it, I guess the lion mane appearance of it, will disperse in about 10,000 years. So enjoy it now, folks. Enjoy it now. Enjoy it while it lasts for the next 10,000 years. Will we last 10,000 years?
Will we last 10,000 days?
The Lion's Head Nebula, we'll find out. All right. Another pretty picture. Now, this one comes from a really fun, incomplete telescope.
Okay.
Incomplete.
Incomplete yet. It's not, or it's a telescope array. It's not complete, but it's called Mothra.
Oh, yeah.
Hell yeah.
Mothra. Mothra shows us a star being recycled in the Helix Nebula. That was the wrong picture. That was not the one I meant to show first. That was like the but here we go. So the lead author of this study is Peter van Dokkum, professor of astronomy and physics at Yale University. This is a planetary nebula, like the Lion's Nebula. The future of our sun, by the way. You can see the very tiny white dwarf in the very center there. It is 650 light years away.
That is little.
It's little, I know.
It's a dwarf.
Mothra stands for Modular Optical Telephoto Hyperspectral Robotic Array.
Yeah, I love it.
We need a Godzilla one.
Can you? I know. It is named after Mothra, for Mothra. Of Mothra Godzilla fame.
Right. No, I got you.
So they really were like, I don't know if they were like, let's find the initialism that matches Mothra.
Completely. I would.
Yeah, so it's not complete yet. When it is complete, it will consist of 1,140 high-end Canon telephoto lenses.
Oh, how many do they have?
I don't know.
How many R5s do they have? Different thing.
The lenses are adept at suppressing the internal diffraction of light that large astronomical telescopes struggle with.
Okay.
And so what is the benefit of this is it can capture detailed bow shocks in these nebulae to study how they evolve and disperse over time, such as with the Helix Nebula. And you can actually see these bow shocks being formed in the outer edges of this image, where you see this kind of, like, it looks like a bow arc, like these arcs of gases that you're seeing in this image. According to Van Dokkum, near the end of their lives, low mass and intermediate mass stars expel metal-enriched material in winds and outflows, ultimately producing planetary nebulae. The ejected material is expected to fragment and mix into the interstellar medium, ISM, but this final assimilation step has been difficult to observe directly. So how that gas and dust mixes with the ISM is what the goal of this is, and to really research how that assimilation and that recycling process happens within the universe. So through Mothra, researchers found 22 bow shocks on the eastern outside regions of the Helix Nebula. The shocks are compact and associated with individual clumps of gas. Here is a grayscale version of the outer edges of this, which I just thought was cool to show. And you can see these
pretty.
You can see some of the, there was another close-up image that I didn't include, but you can see, especially on like the left-hand side, these like darker clumps and even spots, and then the bow shocks that are kind of like around them as it interacts with the interstellar medium. So according to the researchers, the shocks change dramatically with the distance from the central star. Those nearer the center are large, thin, and sharp defined, and then farther out they become smaller, fuzzier, and increasingly fragmented. We interpret these changes as being progressive stripping and fragmentation of asymptotic giant branch shell remnants as they interact with the ISM. So in this grayscale image here, the Mothra image has been... wait, this doesn't make sense. What did I do? The continuum subtracted and given an inverted grayscale to reveal the nebula's faint outer features. The central color part is from the Hubble and Kitt Peak in Tucson, Kitt Peak Observatory. And then the direction of motion comes from the Gaia Observatory. So there's multiple different, basically, the telescopes that are at play here. The Mothra image shows many features at large, roughly greater than 1 parsec distances from the white dwarf that had not been detected in the hydrogen alpha spectra before. So I just thought this was cool and amazing and really obviously pretty. So when they have more examples of this, it'll be interesting to see how the time scale depends on the shock velocities. The study is basically showing now that the final stages of recycling happen about 10,000 years after the star first expels its shell of material, is when then the recycling with the interstellar medium begins. But they really need to confirm with other nebulae and see how these velocities kind of differ between them. So this is like a first test. And again, Mothra is not complete as a telescope array, I guess.
Yeah,
array because it's using a bunch of different lenses to image this. So
1,140 of them.
Yeah, that's a lot of Canon lenses. And
Canon making some money on
this. And I'm like, oh, cool! I got a Canon camera, I guess.
You're part of the array too.
Yeah, I could be part of the array.
She was part of the array last night.
Yeah, I was testing stuff on my new camera that I got. But yeah, so I just thought that was cool and interesting. And you can clearly see that bow shock in them, which is really neat. So pretty pictures and science are what astronomy is all about.
Yeah. Well, it's all about science, but there's a lot of great pretty pictures.
Well, it's all about science, but you get a lot of pretty pictures out of it. The benefit is some pretty pictures. So, it's art and science coming together.
Yes.
Oh, look at that. So full circle, art and science.
Art and science. Anyway.
Cool.
That's what we did. That's some latest astronomy news. Of course, earlier in the show, which was like 10 hours ago, we covered Pisces and the celestial events for September.
It was so long ago.
I know. We had a lot to cover. But, I mean, it just... there's so much research and so many cool things that are constantly coming down the pipe. I actually thought it was going to be like a slow news episode when I first started compiling stories because I was like, oh, there's nothing really out. And then all of a sudden it was like just a bunch of stuff that came out that I was like, oh, this is cool. That I had to include. So there you go. And so in other words, thanks for joining us, everyone, on this episode of High in the Sky for September 2026. As always, we encourage you to go outside at night and look at the stars. Look at what's up there. Just check it out. Even if you don't know what you're looking for, just enjoy and embrace the majesty of the universe that you live in and that we all share the universe together.
Well said.
Yeah, thanks. So follow us on all the things at Drinking Cosmos on Twitter, Cosmos, everywhere else, Spotify, YouTube, our main platforms of getting our shows. Join us next Sunday, back-to-back episodes. Yes. Next Sunday will be
Mysteries of the Moon. I'm making Command Decision.
Decision. Mysteries.
It was either going to be that or the Cosmos of Middle Earth.
Not ready for that.
Not ready for that.
So
the answer to is provolone and Swiss.
Mysteries of the Moon. That will be our last episode of season 7, and then we will take a hiatus throughout most of September, and we will be back. We will be back with a High in the Sky for October, at probably the end of September. We'll let you know.
We'll have to figure it out because we got to figure out dates with stuff.
We have to figure out dates with some conferences coming up. So we'll let you know, but we will be on hiatus. But we will have episodes of The Shot coming out throughout September. So keep your eyes out for that on Wednesdays. And we'll see you next week. Thanks for joining us, everyone.
Cheers, everybody.
Bye. If you're with us live now, stick around because we will be right back for The Hangover. Welcome.
We're back. We did it.
Sorry, that was an extended break.
We did it.
I needed some nuts and I had a plum. Because I only had cereal this morning. So that'll do something. The plum. Oh, okay. So The Hangover. I'm remembering the main show, High in the Sky for September 2026. So check it out if you haven't. But I've remembered Einstein's plant.
Oh,
I want to talk about Einstein's plant. Because we talked about the Einstein probe as one of the news stories in the main episode. So let me tell you a story about Einstein's plant. It's not much of a story. And
then I feel like we need an intro. Welcome to Liz's Story Time. Welcome.
Liz's Story Time. So I went to this sort of art class in town at somebody's house. And we did some. And
you survived. You were not murdered.
I was not murdered. It was fun. We were focusing on mosaics, and so I made this little mosaic fish. I guess I should have brought it in for a little show and tell. So I made a fish with mosaics. Bead mosaics is what the class was. And so, anyway, so some great friends in town that were in this class with me. And class is very informal as far as it's not like a class. But anyway, so the husband of the woman who hosted, because I'm into space, he's very interested in space and astronomy and stuff. And so he pointed out that they have a plant in their house that was right by us where we were doing our art, and it's Einstein's begonia.
Oh, that's fun.
Einstein had a begonia plant, and this plant is from a clipping of that plant. Yes.
That's so cool.
And he offered to give us a clipping of it.
Did you get it?
I didn't, because I was like, I don't know if we could take care of this, but I might. The problem is that Indiana, our cat, will eat plants, and it's a big house plant. So it's like we would have to put it in the Shire room and close the Shire room. But Jackie really likes to sleep in the Shire room.
Well,
I'll tell you, if you get it, mail it to me. I'll take care of it.
Yeah. How's the Pedro's doing?
I still have from 3 years. Still have Pedro going.
Oh, good. Okay.
I got Pedro, Rodrigo. Yeah.
Okay, so we could get a clipping of Einstein's.
I want this plant. I told you that the other day. I want this plant.
I know. Okay, well, we can. I can.
Hey, and
next time I go, I'll ask for a clipping.
If Indiana eats it, can't handle it, some things were just not meant to be.
Okay, well, hold on. Let me Google the poisonousness of begonias to cats. Begonia plant. Poison
dogs
to cats.
Well, our dogs don't eat it.
Yeah, they're toxic to plants.
But what about dogs? Because I could have one. Well,
if they're toxic to cats, they're probably going to be toxic to dogs.
Yeah, but Frodo's built different.
Does Frodo eat plants?
Actually, species and varieties of begonia are toxic to dogs.
So when I clip Pedro, Frodo would try to eat it after it falls down. Yes.
Oh, all right. We can look all this stuff up later.
Yeah, Einstein's begonia. It's an angel wing begonia lineage. Yeah. So after Einstein died in 1955, his secretary and friends shared cuttings with physicists and gardeners in Princeton. And then people continue to propagate and pass down these living botanical heirlooms. And I can't remember who he said he got it from, but it was like a family member or something that got the clipping and everything. So it's legit from Einstein's actual begonia, which is really cool. So I thought that was really, really neat.
Nice.
So if there's anybody watching that, if any of you were watching, anyway, I don't know. Hey, that's cool.
Stop.
Okay. So that was that one thing that I remember to share in The Hangover. What else were we going to share in The Hangover?
We are going to talk about, besides black holes, some of your favorite things in the universe. We talked about the galactic cannibalism. He says one of your favorite things. I thought that's a good topic to talk about in The Hangover. Favorite things that don't include black holes.
Wow.
And dogs.
Blew off the headphone. That no matter where you're looking at, you're looking into the past.
Oh.
That no matter where your perspective is, you're the center of the universe.
The balloon experiment. Everybody get a balloon and put a bunch of Sharpie dots on the balloon, then blow the balloon. Everywhere's the center. And that's how galaxies
I think that wraps it up.
There we go.
That's about it. And also, Mars is the only planet solely inhabited by robots. I think that wraps everything up.
I love that so much.
Yeah, I mean, Liz didn't actually give one, but...
Okay, well, yeah, mine were from the main show, was aside from Stellar Evolution, which I'm known for obviously saying a lot on the show, that I love Stellar Evolution, and the lifetimes of stars.
They don't have lifetimes, they're eternal.
And the various ways that they go kaput.
Don't die. They don't die.
Just like dogs.
Dogs do not die.
Oh, man.
Cats and dogs do not ever die.
Okay.
Stars can die.
Stars can get the fuck out.
They can get the fuck out of here. God, imagine being around for when our sun starts to red giant. I mean, you're obviously like, oh, we're going to die if we don't have another way at that point out. But it's going to look pretty fucking cool, though.
Yeah, it's going to look really cool.
So that's what, 6 billion?
No, a couple billion years.
Couple billion.
A couple billion.
3 or 4.
It's halfway through its life, and I believe from when I was in astronomy class, it was like, in about 2 billion years, it'll start.
Yeah, you're talking
it's
about
gonna
2 to 3.
Start.
Okay. All right.
Moving off of the main sequence.
So by that time, we'll already have merged with Andromeda.
We're gonna at the same
we'll
time.
We'll be a weird irregular galaxy by then.
We're gonna start merging. We're gonna start.
A lot of stuff's gonna happen.
A lot of my favorite things are gonna be happening in a couple billion years. Stellar evolution is happening, and galaxy merger is happening.
You better start eating right, so you can make it to 2 billion years old.
I gotta live 2 billion more years. Where are the vampires? Can we get some vampires? Dear vampires, if there's any vampires that are real and watching, I would like to join your ranks to live another 2 billion years.
Do we have to become their familiars first?
No.
Just like, hey.
You're not like Guillermo.
If I need to be a familiar, it's fine. But they never turn you. They just use you to be and then they keep promising.
That's only if you have an unhealthy relationship with them.
Okay. Well, vampires, and this is to all the real vampires, because real vampires don't fucking sparkle.
And real vampires also just get weak in sunlight. They don't die in it.
No, they should die
in the
sunlight.
Read a book, people.
No, they should die in the sunlight.
No, they don't. They don't die in sunlight.
Burn to a fucking crisp.
That was only with the first film adaptation of Dracula. Nosferatu. Yeah. Before that, the actual novelization of Dracula, they were just kind of weakened in the sun.
Well, I prefer them to burn to a crisp. It makes it more fun.
It's
Put some cheese on that.
So much more dramatic.
More directed. Kirsten Dunst in the little silo waiting sunlight in Interviewing a Vampire.
Thank you, Katie. If they want to put some glitter on,
they can put glitter on, but they don't just naturally fucking sparkle in the sunlight. They're going to burn to a crisp while glittering.
Or just get kind of weakened.
Or...
Anyway...
Welcome to The Hangover.
You know that when you put that glitter on, though, you never get it off.
Or if I could be a ghost. If ghosts can live and survive stellar evolution, how many ghosts in the universe would there be?
But that's only if they have unfinished business.
Oh, I'll make sure I have some unfinished business to be a ghost.
Which brings up the point. If there are ghosts, then vis-a-vis, that means that there are alien ghosts out there, right? There have to be.
Can you imagine? Alien ghosts? That's cool.
Why are there not dog ghosts?
If you're a ghost, can you travel faster than the speed of light?
That's what spooky physics is. Alien ghosts. And that's what Zero is from Nightmare Before Christmas. Is a ghost dog.
Of course you can have dog ghosts.
Okay, but I'm talking real life
ghosts. There should be. And cats. There should be ghosts of all where are the T-Rex ghosts?
I think cats are already ghosts.
Cats
causing all the mischief.
Cats are already haunting you on a daily basis. Yeah, so okay, the goal, we need to live for another 2 billion years.
Yeah.
To see.
I could do that.
Yeah.
Oh my god. That what a perspective from, say, like Saturn or...
What would the night sky look like once you're merging with Andromeda?
I only know 1 million years in the future, thanks to software limitations.
Well, I I get you. I got you on that one. I mean, you see it coming in, right? And
It's
then
gonna get larger and larger.
But
it gets larger and
But
larger.
even okay,
but then like stars start to move.
But the time spans of this though is so
yeah, within
long,
a lifetime
though.
you won't
Right.
know. But
No,
the
in a
nice
lifetime you don't know.
But like the nice, clean Milky Way outline we have in the sky is
Mhm.
going to slowly go away during that merger over lifetimes again. So we will no longer have the nice strip of the Milky Way we see.
Wait a minute. Okay, are we talking about a lifetime, current lifetime?
Lifetime
Say,
of an age. Like imagine you're Gandalf, right? And you die, you come back thanks to
Gandalf's
Galadriel, and then you come back. So that's
Gandalf
what I'm
is
talking
immortal.
about. Like thousands
Gandalf
of
is
years.
immortal.
Well, and he went from gray to white. Didn't he die during the gray phase to become the white, reborn as the white?
Yeah, but technically he's immortal.
Okay. So
It's just
vampires.
like
It depends
Gandalf
technically
is a
how you
vampire.
define immortal now.
yeah, it's just like Sauron is
Okay,
quote
okay.
unquote immortal.
Okay, but
Just like Morgoth
also
still exists today.
Yeah.
let's talk about the perspective of Andromeda in the sky. Okay, so
Okay.
currently, if you look, you can see with a dark ass sky, you can see the Andromeda galaxy out of the corner of your eye. Best way to view it, and it just looks like a wisp,
Averted
a
vision.
puff, a faint, a ghost
Nothing
of
but
a
a puff of smoke.
galaxy. And in a telescope,
Clouds.
it looks like a cotton ball, basically.
So many Lord of the Rings references. I'm glad
It's not the
that
main show.
that the rule has been suspended.
Andromeda
for
in a telescope then looks like a cotton ball. It's still a faint
That's
cotton
nice.
ball, you know. So then, but if you could see, if you had not just visible light in your eyeballs and you could actually see the Andromeda galaxy in the night sky, it would take up how much of the night sky is it?
Oh, it's just
5 full moons?
Yes, 5 full moons.
So
It's not like huge, but
It's still
a
5
lot
full
bigger.
moons in the sky is a lot bigger than the wisp out of the corner of your eye
Yeah.
that you can currently see.
Because you're really just seeing like the central part of it.
Yeah,
Mhm.
so it takes up a huge amount. It takes up a decent amount of night sky, considerably.
Yeah,
Okay, so then as it gets closer,
it's gonna get a lot fucking bigger.
I mean, then it's gonna be like it could eventually be amazing in the night sky.
Yeah,
2 billion years.
So I mean, the really cool part is that like right now it's just that wisp.
Yeah,
But then as it gets closer, you do, oh, wow, this is like the size of a full moon. Oh, wow, this is even bigger.
would we be able to?
Even bigger.
But
and
that
bigger.
will have to replace, because right now we have Saturn as a jewel of the solar system. But by the time Andromeda gets close enough to look like that, Saturn's rings will be gone. So Andromeda will then overtake Saturn. Is the best thing to look at in the sky.
Well, okay. I think that here's the thing. A lot of this shit that we see in the universe is just to the universe like right now. Saturn's rings, for example, they're transient things. They don't last forever.
Sad.
Like the Lion's Nebula.
Sad.
You know,
Remember.
however many years it will dissipate.
10,000
right?
years, 10,000 years.
10,000 years it'll dissipate, which really is not that long. So the thing is like right now, at this instant, living in the moment, Saturn is the jewel, arguably. I mean, you can make an argument other things are, but
It's honestly
beautiful.
probably the Earth, honestly.
so
Yeah.
Saturn is the jewel of the
Just 'cause it's
heavens,
blue.
right? But in 2 billion years, you're going to have all these other things that don't exist right now. And
Imagine all the things that we missed because we haven't had telescopes and
Exactly.
shit, or because people didn't know what the fuck they were looking at.
imagine the dinosaurs, since Brandon, you brought that up earlier in the
What
episode.
did the dinosaurs see?
You know, there were things that the dinosaurs got to.
Well, a
If
huge
they
asteroid
had
coming
big ol'
towards them,
asteroid,
that's
yeah.
for sure. Yeah,
If they had telescopes, they would have been able to
they
see
got
that
to they got to
asteroid.
live their Armageddon without Bruce Willis.
Yeah, yeah. Don't we have a shot? I did a shot on
Yeah,
that,
you
right?
did a shot.
Okay.
It's coming out next Saturday.
Oh shit! Sorry, guys.
No, it already came out. I'm sorry,
right,
it's
that's
already
what I
came out.
thought.
The day the dinosaurs died. Check it out on YouTube and
The
Spotify now.
day the dinos
So-
died.
You know,
It's
I
very
think
Bowie.
Arr, rawr.
all right. So I dabbled a long time ago. I dabbled in Buddhism.
Oh, you dabbled.
dabble.
Stuck your toes in.
I dabbled in it.
Yeah, because it's more of a philosophy than a religion.
It's more of a philosophy. But one of the central things is in Buddhism is impermanence, right?
I don't like it. I'm sorry.
That. Okay. All right.
Let's go on.
So nothing in the universe is permanent, which means like the rings of Saturn and stuff like that. What?
Boo.
Okay,
Boo.
I'm sorry. I'm sorry. But so your reaction like took me aback.
I'm
so
sorry.
I completely forgot where I was going with this.
Sorry.
Oh my gosh. Yeah, so everything in the universe, all these things that we see that we are just have fallen in love with, none of it's permanent. And there's like this whole like deeper meaning in Buddhism where nothing is
even
quote
the
unquote
universe isn't permanent.
No, God no, because the universe is expanding, right? And so at this moment right now, the universe is in one state. Now it's in another state.
Is it the heat
Atoms
death or
have moved.
Cold death.
What?
Is it a heat death or a cold death?
Oh my God. Well, well, it depends. Like it's like we don't. So we know that the universe is accelerating, right? Which is going to that implies a cold death. But if for whatever reason
it's so cute,
we're able to arrest that out.
What a good boy.
If we're able to arrest that movement out, that expansion out. Okay.
Sorry, no, keep going.
I'm listening to you. If you are
you
able
needed
to
be
expand that universe
apologize.
out,
then arrest it and contract, then it's a heat death. But
there's nothing that we know that could pull it back in to have that heat death.
Gravity can do it. We just don't know if there's enough gravity to do it. That's the thing.
But then when it contracts itself back in, it may just bounce back out.
But how would gravity contract? How would there be enough gravity to contract it back in when everything is spread apart and that's what has the gravity? It's everything that has the gravity. Everything expanding has the gravity. So what's the gravity that's going to bring it back in?
So you're thinking as if you imagine like the trampoline idea, right? Like you put a bowling ball on a trampoline, it bends.
It's called a big crunch. There's a name for it.
Yeah.
It's called a big crunch.
Yeah.
And
so I get Taco Bell.
That's the gordita crunch.
I mean, they're missing out like Taco Bell. Hey, the big crunch. This is a cosmic crunch that you
make it saddle shaped.
Or just flat because the universe is flat, even though it's saddle at the same time.
Right. So, all right, space-time is expanding.
Sure.
Yes,
I'm saying sure as in yes.
Oh, okay. Because
not
the look on your face was like
sure. No, sure, yes. Okay. It's expanding. Dark energy.
Yeah, space-time is expanding.
Yeah.
It is taking galaxies and matter with it.
Yeah.
However, if there is enough mass in the universe, that mass will stop moving out and then collapse back down.
Oh. Yeah. But if most galaxies are say like 90% done forming stars, then there's not much more mass that can be made.
Okay, but all right. So you're just transforming matter from one state to another state. So the matter of a galaxy stays the same.
Conservation.
Yeah, it's basically a conservation. You're just changing it from a cloud to a star. You're concentrating it more.
It's like an ice cube. So the mass, the same amount of
mass
water.
stays the same.
Right.
The only thing is like that. Okay, so with that statement, mass stays the same for the galaxies. It's not entirely true because the galaxy is radiating energy. And that energy has a certain mass associated with it. And so that little photon might just be, we'll just say a little photon of gamma rays and a really small energy, high energy for light, but, but it still takes a tiny, tiny little bit of mass away.
Where does it go?
Out into the universe. But
itself?
at the same time, though, but the total mass of the universe stays constant.
Well, because it's still a part of the universe.
Right. You can just transfer.
We don't have evidence of anything leaving the universe because we don't have any evidence of anything outside of the universe. And then my brain melts. Goodbye now.
It always gets reminded of that Robert Frost poem, Fire and Ice.
Yeah, you asked like I read things.
Mike had a moment there. He said, yeah, that makes sense. I have it up if you would like to hear it.
Yes, please. Please.
Some say the world will end in fire. Some say in ice. From what I've tasted of desire, I hold with those who favor fire. But if I had to perish twice, I think I know enough of hate to say that for destruction of ice is also great and would suffice. Basically, burn it all down. If burning doesn't work out, freeze it out.
Either or.
So, I mean, yeah, the question is, to me, the end result, either result is just a fascinating thing to observe. Like, you're coming together. Imagine the universe coming together in the fire scenario.
Which would take an incredibly long time in itself to do.
Yeah, it's going to take,
So we need more than 2 billion years for the vampire.
Right. So, we
need a doctor.
Right,
yes. So the universe brightening and all that would be fascinating to see all this stuff come together.
And then,
but in the ice
everything
situation,
go into just darkness and nothingness.
But that to me also is
the beauty of
a fascinating thing where you are on a planet going around a star
with no stars.
And the galaxies slowly
blink out of existence.
Yes, they blink out of existence.
And
then, but we're not done there. And then the stars slowly begin to wink out. And then you are on a civilization, on a planet, around a star, and you think you are literally the center of the universe again, and that there's only one star in the universe, and it's just that everything is either winked out or is beyond the light horizon. So you're on this planet in a galaxy thinking you're the center of the universe. Meanwhile,
you're back to the island galaxy.
Yeah, but just over the light horizon, just barely over it, is another guy sitting on a planet in a galaxy thinking we're all there is.
What would you rather experience?
What I'm saying is that there is a really cool aspect to both from a very philosophical point of view. One is very lonely. Very lonely.
So which one would you rather experience? The planet where you have every fucking galaxy coming towards you, or nothingness?
I mean, I think
you look up and there's nothingness.
The isolation of death makes me feel important because I am all that is.
Brandon wants nothingness around him.
I think that coldness is less painful than the fiery death. That's
a good way of putting it.
The fire is more dramatic.
It's dramatic, but nobody's going to remember the dramatics.
No one's going to remember any of it.
Well, yeah, there won't be any memory.
I also want to point out that Mike and I have both said blink out of existence. There's a great short story by Arthur C. Clarke called The 9 Billion Names of God. So if you have time, it's a very quick read. It's a short story. Go read 9 Billion Names of God and watch the stars blink out of existence.
Yeah, it's a very. I haven't read it. I think I'll add it.
There was another thing we just passed earlier this month. There will come soft rains. You ever read that one?
There will come.
I think that's another Clarke short story. There will come soft rains.
Oh no.
Let me just make sure of that. There will come.
Send it to me.
Soft. Oh, Ray Bradbury. So I bring that up because it was written in the 1950s, but it was set in like August, 6th of 2026. So we just passed that date of the Welcome Soft Grains.
Okay.
And it's very nice. I'll just leave it at that.
Do you want to tell more, or do you? Okay, all right.
Well, it depends. Do you want this? There's not much of spoilers. So the idea is it is an automated house going through its routine of here's a toaster, here's the AC, here's the dryer, here's the opening of the blinds, but no one is around because everyone is already dead. So it's the house doing its routine for the same day for decades upon decades and decades. So the machinery will still last after the people are gone.
There's a Google automation that never was told to
Yeah,
stop.
but that was earlier this month, 2026, from the vantage point of the 1980s.
Wow.
Oh,
nice.
wow. Okay. Interesting.
Meanwhile, we have refrigerators that talk to our phones and
that we can only adjust the temperature through our phones because I can't figure out how to do it by pressing the fucking thing. I want the heat death of the universe. I want the crunch to happen. I know that it's not going to be the crunch. It's definitely. It seems like it's going to be.
Well, that depends what new physics tells us.
The not crunch, the non-crunch.
Yeah, I feel I think I agree that it's more dramatic.
Here's the thoughts.
And visually would be amazing.
Here's the best of both worlds.
Whoa.
Both.
Okay.
Yeah. So we want the big crunch, we want the big freeze at the same time, but what if as well there are multiple universes? And because galactic cannibalism exists, what if there is universal cannibalism, cosmic cannibalism, and we get devoured by another universe in some way? What that would look like, I don't know.
In a long, long time ago in a universe far away?
There we go.
All right.
Take a drink.
Here's a scenario. With Big Crunch, right? So
all I'm picturing is a Crunch Bar. Anytime someone says Big Crunch, I'm picturing a Crunch Bar or something from Taco Bell now.
Crunch Bar is my favorite chocolate bar.
Really?
Yeah, hands down.
I like a Mr. Good Bar because it's what my grandpa always had for Halloween.
When I would go to my grandmother's, she would get a whatchamacallit.
Oh, whatchamacallit?
That's the name of the thing.
That's the name, whatchamacallit.
All right.
You haven't seen those? Whatchamacallit?
I'm a Phoenix boy. I know what whatchamacallit is.
Okay, I thought it was universal.
Nice. Anyway.
All right. So, Big Crunch. Universe is collapsing in on itself. However, there is a thing in physics where protons are not exactly stable. They do not last.
They're a little crazy.
They're crazy. Yes. They're crazy in that they split up. They disintegrate.
Oh,
yeah. The half-life of a proton is just so incredibly long. It's just they're basically.
But it exists.
But it exists. So, what if there's a big crunch, but that crunch is the age of the universe is so long that it matches up with the half-life of
your protons. It's like Marvel's Endgame. Y'all just disintegrates.
Yes. And so like half your protons just kind of disintegrate.
Would that be painful?
Well, I mean, half your protons are disintegrating.
What do you
what
happens?
I can't remember what it disintegrates into, but part of it is energy. And so you just have all this energy that kind of
the world is made of energy.
Ghosts happen when half your protons disintegrate. You become a ghost.
I think
that's what happens to vampires in the sunlight. Half their protons disintegrate.
All right, I'm good with that.
There's our compromise.
Oh shit! I thought about the thing I mentioned that I wanted to do in The Hangover. We'll do it in the next one.
Well, no. What do you want to do?
We got another week. Listen, we're already in 2.5 hours at this point. We can do most of the Lord of the Rings movie during the show. I was going to show up my cool stamp collection. But I'll do it next time.
No, show them.
I don't know exactly where they're at. I'm pretty sure they're in that closet right over there.
You're supposed to find them.
I have to pee.
All right.
So I'll get them next time. We'll talk because it is space related.
Okay. All right. So
it is cool.
Next time. All right. Mysteries of the Moon.
And stamps.
And Brandon
stamps. Oh my God. We can talk about the Apollo mission that took the stamps to space and the astronauts kicked out because they took the stamps to space and tried to sell them. It's a whole thing.
We have
a whole nother episode.
Are you gonna do
next
it?
Episode.
Are you gonna do it? Are you gonna talk about the guy yesterday?
Yeah. So we went to we had a concert in the park yesterday in our local town here. And so they had a few vendors. Usually they have more vendors, but anyway.
Yeah.
They had a few vendors, and one was like Dark Side something. So it was a Star Wars pun.
It was like, let's not
barbecue.
Name them.
Oh.
Let's not name them.
Well, I named them. Nobody watches this. Anyway, we bought a barbecue sauce and a rub. The barbecue sauce, it was the sweet and smoky, and it tastes really good.
It doesn't have any heat. Your mom would like it, I think.
I'm excited to use the rub that we got on the ribs that we have in the freezer because it's like a river or something rub. And I was going to get a coffee one, but he said, what are you going to be using it on? I said pork, and he said, I recommend this one instead. So I went with his recommendation and got the river whatever rub that he recommended. Anyway, he had a bunch of Mandalorian, Boba Fett, and tattoos. And of course he saw Mike's tattoos, and so there was a tattoo conversation that ensued on that, and noticed his space tattoos with his Apollo tattoos and Saturn V tattoos. And then he proceeded to ask us if the Apollo 11 was real, or if they didn't land until later in 2012 or whatever it was.
2012?
No. He said Apollo 12 or 14. So it was not 2012.
No, he said 2013.
No, he said Apollo 12. He said Apollo 12 or 14.
Okay,
he just thought it was later missions, Apollo 12 or 14.
Yeah, so anyway, he thought it was later missions, and we were like, no.
Apollo 11 was real.
No, but anyway, so yeah, he was on the more of like it happened later in reality and before.
By later means like 8 months? Like what's...
I swear he said 2014 or 2013.
No, it was... I think I can...
And
I swear
maybe
I
was misinterpreting him, but...
I swear I think he said Apollo 12, and he skipped 13, which was good, and said 14.
So anyway...
he was
really nice, and we had a really good conversation. He was very friendly.
And what the fuck did 11 do for this couple of days?
And actually quite knowledgeable on things.
Oh, sure.
He was actually very knowledgeable on
the best con men are.
But no, don't talk to a con man.
He's not a con man.
He had like some decent stuff. It just his belief.
I mean, listen. If he says Apollo 11 didn't land on the moon, then.
No, he's not a con man.
Skeptical of it, which then we're like, all right, there's plenty of evidence to show it's not.
I appreciate how you both jumped to the defense, so that lends to the credence that he's a good guy and he has good intentions behind it.
He's got good stuff.
I can respect that.
We named the thing in here, so we don't want to say that he's not.
Yeah, but also, even if we did not name him, I would say that
misguided.
You were still respectful of it, which is very nice.
Yeah.
And I did tell him, do not say that to Buzz Aldrin, and he knew exactly what I was talking about.
Yeah,
he's old.
Yeah.
But he would still hit you, and he still would get away with it.
Yeah.
I hope so.
But also at the concert in the park, there was one band that played, and we don't know their name. I didn't grab it, but it reminded me the songs that the couple songs we heard, not lengthy as such, but reminded me of this Decemberance song you always play when we do golf with friends. And I was like, Brandon would totally like this brand. I also thought Adam might like it as well.
Their first song really felt...
I'm not going to sing it.
No, their first song felt like something that you would hear in an Irish pub, but with American accents.
Yeah, but they had two stand-up basses, an acoustic guitar, and then one like the singer with the acoustic guitar had a drum pedal.
Yeah,
drum.
Yeah,
he's doing the epic sea shanty.
It was storytelling music, and
it was very sea shanty-ish.
Yeah, and for what it was,
I enjoyed it. I enjoyed it. But yeah, we're like, I was like, after you mentioned I was like, it sounds like that one song from that Brandon always played. And then I was like, yeah, Brandon would like this. But I did make the comment first that Adam might like it, ironically.
Yeah, and so it was...
They were actually not bad. I respect them. I enjoyed them, actually.
I mean, we did end up leaving. to
Go
rescue
home
the pups,
and
but
have some real drinks
and have some real drinks.
Watch-
There
watch
was a whole
Mandalorian
thing about
and
like beer and
Grogu.
stuff, but if we had stayed, I don't think I would have disliked it.
Yeah.
It was, I enjoyed it for what it was, and
do you imagine that if there is some other intelligent species out there in the universe, obviously they would not be humanoid because that would be a ridiculous premise.
Would they hate
But
country music?
what if
Yes, they would.
if it turns out that these 5 phalanges is actually the optimal method of doing things?
I mean, if it's like spherical things being the least
Yeah.
energy,
and we can grab a spirit.
I mean, we can't say how evolution works and what it does.
That's why there's a baseball with spherical.
No.
It's just that it would be very
No,
egotistic to think that
But
there
we
would be
know
other
how evolution
humanoid.
works.
Yeah, but to have it to be a humanoid end result as a peak evolutionary.
Listen, if you want to survive as a species, you have to be. What's the word? You have to want it more than the other species. You have to be.
Yeah, but it also depends on your
But
environment.
You have to be
that
an
you're-
asshole.
I am not
We're good
going
at
to
that.
say that our design, humans' design,
evolutionarily
is
speaking,
evolutionary
not
optimal.
other words. Yeah.
But
Only 'cause of thumbs.
what?
in the concept of the Earth, it is.
Not necessarily.
That's why we're here.
But there could
No,
be silicate-based life.
we had
No.
so many. Yes, we had
No.
many instances of luck. We had many instances of luck to
Luck
get
is
us
part
here.
of evolution.
What allows humans to still be here, I think, is our big brains.
Yeah.
Yeah, so I'm saying you don't need thumbs.
No.
Oh, and here's another thing. Go ahead.
All I'm saying is that the 2 arms and all this kind of stuff and where everything is in our body isn't necessarily the most.
That's what I'm saying. Like, it's not a humanoid thing. I'm saying not humanoid. It could be
and
ethereal based.
and
He just makes himself look humanoid.
Somebody says something about optimal though, and
This is kind of going off track again.
All right, but anyway, go ahead, continue.
Well, I started it. What was I thinking?
But,
okay.
No, my original premise. Shut up. My original premise was intelligent life, not humanoid necessarily, because that would be a fucking stretch throughout the universe. But what is there? Would there be? Could there be? What would it be? Music.
So there's a book. It's called Saturn Run. It does fine. The prose is mediocre at best. Story is fine, but they do go into depth into what other life forms would be interested in, and they actually talk about music, like things with strings, not terribly interested in, because anyone could put a string together, pluck it, and see what happens. So they weren't interested in string, Bach, Mozart, Mendelssohn. They weren't interested in that. They were interested in more experimental stuff. So that's that part.
Like EDM.
Honestly, yeah, I don't remember what it was, but yeah, it was something like that.
What's the electronic music phase that happened? Was it
house music?
Not house music.
No, it's EDM, right?
No, EDM. But what's it called? No, but there was a specific genre. Somebody help me out.
We're no longer in that phase
we're not
of our
in
lives
it, but it's
like
like
music.
Like but it's called something. It's
called
house
music.
Not house. It's
That's
not called house music.
House
It's
is
called
not
like
house.
it's like fuck.
Boots and pants. That's EDM.
No, but it's but it's called something. There's
It's called boots and boots and pants music.
It's called boots and pants.
Boots and pants.
No, but there's some other name for it. I'm
old.
I'm
no longer
older than you.
Jeez.
Oh no, it's right there. It's right there. It's
Okay.
like people that are into like heavy electronic music, and it's like it's
right. What was the thing I was gonna say?
Dubstep.
Dubstep?
I got it.
Dubstep.
Dubstep. I got it. Dubstep. I found it.
I had a thing I really wanted
That
to say.
is.
Oh, yes, okay.
That is different from EDM.
It's like
Alright,
heavy
I'm gonna-
EDM, basically.
I'm going to take
so it's
us
a
back
subgenre.
from EDM,
I don't
get us
know.
back
Subgenre.
into the universe, and then that way
metal.
Liz can take us home.
Okay.
All right. So we've talked about, in the main episode, the HR diagram. We talked about
Pisces.
We talked about so many things in the
We
main
did. We have a
episode.
lot
And
of
the
stuff.
Hangover, we talked about galaxies, the heat depth, the cold depth, all these things. We talked about, don't mention black holes, but
Or quantum. I wasn't allowed to talk about quantum
or
either.
quantum. But in my mind, no pun intended here, I honestly think the most intricate and the most interesting thing in the universe, until we find something different, is the human brain. I honestly think that everything we know of supernovae, of the galaxies, of the dark energy and the human brain is the most complex and most intricate thing and I would die on that hill. And if you want to see me, let's do it right now.
No,
What's more complex than the human
okay.
brain?
But we
And
don't
it's
know of anything in the entire
Is-
universe of possible life that could exist.
Yeah.
Just Drake equation
No,
itself.
he says that we know of. He
That
said
we
that
know
we
of.
know of.
Okay,
That was
that we
my qualifier.
know
He said that we
of.
know.
Yeah,
So
that we know of.
No, I agree with you. And
Dolphins
it's
and
not,
octopus are pretty smart.
It's not the complexity.
They just don't have thumbs.
It is the
No,
yes.
hold on.
If octopus have thumbs,
Right. It's not for me. For
Mhm.
me, it is not the complexity because anybody can make anything complex. It is the fact that we're able to abstractly think about the universe and that we're able to understand things that to be honest, Jackie, Leia, Mr. Frodo, Indiana,
well, yeah.
they cannot.
Let's talk to an
No.
octopi.
And we have more
Yeah.
neurons than stars in the Milky Way.
That's cool. That's cool. And it's the fact that we're able to abstractly think and that we're able to understand the inner workings of stars and not be there
Oh,
experiencing
yes.
it. To understand the laws that govern the universe. And
There's definitely
Finish it
a
off.
species doing it better.
atoms
Finish it off
that
with
we
the
cannot
great
see
Sagan
and
quote.
quarks that we cannot see.
Leptons.
Yeah, all of that.
They're up, down, strange, and charmed.
Yeah, and so
And
we're a way for the universe to know itself. And to quote Sagan, there we go. And I think that is the amazing thing about the brain, the human brain. And and you know what's crazy is that we waste all this brain power on shit that doesn't fucking matter.
To end on a happier note.
Yes.
I agree. I definitely agree. But there is a moment when I do my little astronomy demos to people that probably don't care about astronomy, but they get roped into it because that's the story that we weave going out. We see, all those trillions of galaxies out there, and they're all made of hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, all the stuff. But I do need to start adding this in that, yeah, we're made of the same stuff. We're made of the same shit. So that just means that we are the cosmos knowing itself.
Yeah, exactly.
And that's why I don't feel the existential crisis way off in the distance, looking at all these trillions of stars and doubled out of the planets. No, we're made of the same shit. We are a way of knowing ourselves. Liz?
Very good. Thank you. And thanks for joining us on The Hangover.
Join us in a week where we talk about the mysteries of the moon.
Mysteries
so
of
back
the
to back.
moon! Oh, provolone? Swiss? Ugh, gross.
Blue cheese? No.
Oh, blue cheese.
I don't like.
is
I don't like
phenomenal.
blue cheese. I'm not a fan of blue cheese.
Pepper jack?
Pepper jack's better.
Maybe it's spicy.
Gorgonzola. I can do gorgonzola.
Ooh, brie.
Anyway,
Brie
join
solid.
us where we answer all the cheese questions
Oh,
in 1 week.
that
So
shit.
back to back, and that'll end the season. And also, Brandon will share his stamp collection.
Hell yeah, I will.
Brandon.
Cheers, everybody.
Bye, everybody. We'll see you in a week.
Follow us all the
Bye.
things.
Okay, goodbye.
Smash that like and subscribe.
I ended it right after you said that. It was perfect.